In June 2025, we saw that they brought electrolysis for the question one. So let's read. A group of students conducted an investigation to determine the products of electrolysis when dilute aqueous copper 2 sulfate solution was electrolyzed using copper electrodes. So very simple electrolysis of copper 2 sulfate using copper electrodes. We see that CXC has been testing this ever since inception over and over and over. The following steps indicate the procedure used. The copper cathode was first washed in distilled water, dried and weighed. So I want you to pay attention to distilled water, washed in distilled water, dried and weighed. Because coming down to the end of the question, they would ask you something related to that. So it's very important when you are doing your lab questions, um, mainly your question ones, it's very important to picture what is going on in the question. So basically, put yourself in the lab as you would have had enough lab experience. Put yourself in the lab and try to understand every single step and see yourself doing every single step. So the first step again, I'll read it. The copper cathode was first washed in distilled water, dried and weighed, and then connected to a suitable circuit. Step 2. A current of 0.2 amps was passed through the solution and the starting time recorded. After 5 minutes, the switch was turned off and the cathode was removed. Rinsed with distilled water and dried in air and then weighed. So it's important to note that after 5 minutes, the switch was turned off, the cathode removed, rinsed with distilled water, dried in air, and then weighed. So they didn't use any external drying methods. For example, for example, um, drying under heat. They dried in air and then weighed. Number 4, the cathode was returned to the circuit and the process was repeated, recording the mass of the cathode at 5-minute intervals. After each interval, the cathode was rinsed in distilled water, dried in air, and weighed until a total of 5 readings were taken. So let's go on to the question now. Define the term electrolysis. Electrolysis is the decomposition of an electrolyte by the passage of an electric current. What is an electrolyte? An electrolyte, we have to remember that an electrolyte is the solution that we are trying to decompose. So electrolytes come in the form of a solution, and once we pass an electric current through the electrolyte, it will break up into its constituent ions. So the definition of electrolysis again is the decomposition of an electrolyte by the passage of an electric current. Part 2. State one difference between the anode and the cathode. The anode is the positive electrode. So it's important to remember that anodes attract anions. Anions are negatively charged particles. So the negatively charged particles would be attracted to the positive electrode. Cathode is the negative electrode. Cathodes attract cations, and cations are positively charged, so therefore it will be attracted to the negative electrode. Everybody okay so far? You can just message in the chat and let me know if you need anything re-explained or anything of the sort. Great. Part 3. Complete table 1 by recording the mass of the cathode after 10 minutes and 20 minutes and the mass of copper deposited after 15 and 25 minutes. So here we have a table to fill out, right? But this table, we don't have to take any readings from anywhere. We have to calculate it. So if we look at the table, at 0 minutes, the mass of the cathode is 11.80 grams. So we can deduce that the mass of the original cathode, with no mass deposited, no extra mass deposited, is 11.8. So we can say that the mass of the cathode at 0 minutes is 11.8 grams. At 5 minutes, as you see, we go from 11.8 to 11.83. It has increased, right? So it has increased. If you take your calculator and you put 11.83 minus 11.80, you will get 0.03 grams. So in order to get the actual mass of copper deposited, we take the original mass and we take the mass of the cathode at each of the 5 minute intervals and we subtract it. This one was missing, which is the one that I did. I already have answers on the paper, as you could see. So these were the ones that were missing, right? So at 5 minutes, the mass of the cathode was 11.83 and the actual mass of copper deposited was 0.05. So in order to get the actual mass of copper deposited at 15 minutes, we saw that the mass of the cathode was 11.87. So therefore, in order to get the actual mass of copper deposited, we would have to take 11.87 minus 11.80. 11.80 and we end up with 0.07. So that is how I ended up with this number. So let me just write a general formula for you. It's the mass of the mass of cathode minus mass, original mass. Original mass of cathode, right? So mass of cathode, which are these masses here, minus the original mass of the cathode will give you your actual mass of copper. Now we have to find the mass of the cathode, which is 11.89. I'll come back to this one. I realize I forget out this one. 11.89. So we have here, we have to find the mass of the cathode. So if we have to find the mass of the mass of the cathode would be your original mass add your actual mass. So your original mass being 11.80 add 0.09. This is at 20 minutes. So 11.80 add 0.09, which would give you 11.89. Let me come back to 10 minutes now. We needed to find the mass of the cathode. So again, it would be mass of the cathode equal to original mass add actual mass. So mass would be original mass add actual mass. That would be 11.80 add 0.05 to give you 11.85. 11.80 add 0.05 to give you 11.85. Finally, the last one at 25 minutes, we would have we have to find the actual mass. So the actual mass would be your mass of your cathode and your original mass of your cathode and your mass of your cathode at 25 minutes. That's what we have to deal with. So to find your mass, your actual mass, that would be 11.91 minus 11.80. Let me just check back. That's in the calculator. Y'all could check it for me. 11.91 minus 11.80. 0.1. Not 0.01. So 0.1. Is anybody taking down the answers? Or you would take it down when the recording goes up? So this here have to be 0. Okay, no problem. 0.1, right? So table 1, we filled out already for 4 marks. You had 4 places in which you needed to fill. So that would constitute your 4 marks. You have here, 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 and here. So let's go to part 4. Plot a graph 0.11, 11.80 minus 11.91. 0.11. All right, my bad. Okay, thank you. So let's go to part 4. Plot a graph of actual mass of copper deposited versus time. Using the axes in figure 1 on page 7, draw a line of best fit through the points. So I'm taking these off, and I already would have the line plotted here. So let me just draw a line through it. Everybody could see that? So always remember for your graphs, how much marks is this graph? This graph is 4 marks, right? So always remember for your graphs, you need to label your axes with your units. So we have the labeling of the axes here done by CXE. We have the title of the graph, and you need to put a scale. We have a broken scale for the y-axis, and we have a regular scale for our x-axis. So if we turn back to the first, actual mass versus time. So actual mass versus time, right? Remember, we have a broken scale, so it would not be going through directly. It would not be going through the origin. So actual mass of copper deposited 0.03 to 5. So 0.03, 5 minutes would be between 0 and 10. So our first point would be this here would be 5. This here would be 5. Our next point would be 10, 0.05. Our next point would be, so 10, 0.05, 0.07, 15, 0.07, 15. So 15 is in between 10 and 20. 0.07, 15 down here. Next is 20, 0.09. So 20, 0.09, and 25 would be the 0.11 we found earlier, right? So I made a mistake in writing it, but my calculations was 0.011. So I did it correctly in the graph. 0.11 and 25, smack in the middle. So everybody could see that the graph gives a straight line, no best fit, straight line, straight to the point graph, right? So let's see the other questions now. I'll bring back the graph in a bit. Use the graph to predict the mass of copper that would be deposited after 28 minutes. So you see, they tell us to use dotted lines on the graph to show how you obtained your answer. So 1 mark for your answer and 1 mark for dotted lines. So let's use the dotted lines. They want 28 minutes. So 20, if we have here is 20 and here is 30, how many blocks we have in between? 1, 2, 3, 4. 1, 2, 3, 4, 5. So we want to find how much is 1 block. So 30 minus 20 divided by 4 lines divided by 5 blocks. So this is 22. This is 24, 26, 28. So good. We have our graph. We just have to, let me just zoom out a bit so we could get the entire graph. So let me draw back the graph. And 28 would be right here. So if we go straight up, you use dotted lines. Go in, we would reach right here. So in your paper, you can use dotted lines. So it would just take long for me to do. Can anybody tell me this point? What y'all got for this point? Anybody can read it off? Yeah, correct. 0.121. So I got 0.121 as well. Now, CXC would give you 0.121 or 0. Probably 12. It would be dependent on how you draw your graph, right? But I don't think it should vary. I don't think it should vary more than 0.121, right? Because the graph is pretty straightforward and it goes through all the points. So everybody could see that this point here is 0.121, right? All right, so let's go. Write an ionic equation to represent the reaction at the cathode. Can anybody tell me what happens at the cathode? Is what type of reaction happens at the cathode? Is it oxidation or is it reduction? Anybody? Why do we say oxidation? Look at the ionic equation on the board. Copper 2 plus ions plus 2 electrons, forward arrow, copper. Oxidation, if we remember oil rig. So if we remember, I'm not sure how you all would have learned oxidation and reduction, but if you all learn oil rig, you would remember that oxidation is loss of electrons and reduction is gain of electrons. Here we are starting off as copper 2 plus. So we are going from 2 plus, we are taking up 2 electrons, and we are becoming copper 0. So does that mean that we gained electrons or we lost electrons? Thank you, Lani. Anybody else? Okay, no problem. Loss of electrons. Anybody else have anything to say? It's actually gain of electrons because the hold on, the copper 2 plus aqueous plus 2 electrons. You are gaining the 2 electrons to become copper 0. Everybody understand that? Remember, the copper 2 plus means that it's already lacking electrons. It means that it's already lacking electrons. So because it's already lacking electrons and it gains the electrons, it becomes the copper solid. Everybody understand that? So at the cathode, we have reduction happening. We have to remember that when we have a positive ion, we are lacking electrons. So because we are lacking 2 electrons here, we have space for 2 electrons. So we gain the 2 electrons and we become solid copper. Solid copper being deposited at the cathode. Everybody understand that? Good. Right, so let's go with the other question. Calculate the quantity of electricity that passed through the copper sulfate solution when zero point 0.2 amps of current flowed for 20 minutes. So calculate the quantity of electricity that passed through the copper sulfate solution when zero point 0.2 amps of current flowed for 20 minutes. So is this unit of time acceptable for our calculation? It isn't because we need to turn minutes to seconds, right? We always have to turn minutes to seconds. So this is where you would see I take 20 and multiply it by 60 in order to turn it to seconds. So the quantity of electricity Q is equal to IT. So I being current and T being time. Current is zero point 0.2 multiplied by 20 minutes multiplied by 60 seconds. We get 240 coulombs. Everybody okay with that, right? Simple, straightforward equation. If anybody here is also doing physics, you would understand it's just simple substitution, right? Calculate the number of moles of copper that would be formed. Given that 1 Faraday is equal to 96,500 coulombs. So we all, when given or when doing any type of equation in electrolysis, when doing any type of calculation given electrolysis, we always have to reference our equation. And we have to remember that we gained 2 electrons, right? So because we gained 2 electrons, we can now we can now make that relationship with 2 Faradays being equal to 1 mole of copper because we took 2 electrons to make 1 mole of copper solid. Because of that fact, from the actual equation itself, we can say that 2 Faradays is equal to 1 mole of copper. We remember that our Faraday's constant is 96,500 coulombs. So we take 2 multiplied by 96,500 coulombs equal to 1 mole of copper. Remember, we want to get the number of moles of copper that would be formed. So therefore, we calculate, we get 193,000 coulombs equal to 1 mole of copper. So what I would do in this case, because I want to find for 240 coulombs, I would use unitary method from math and I would find for 1 coulomb. So when I find for 1 coulomb, it's 1 divided by 193,000. And then I would just, in order to find for 240 coulombs, I will take 1 over 193,000 multiplied by 240 to get 0.00124 moles, right? Take a minute and recheck the calculation. Take a minute, and if anybody has any questions, if anybody disagrees with what's on the board, we could discuss it. So just remember that because we have 2 moles of electrons being deposited or being taken up, we will get, which it automatically um, applies that 2 Faradays equal to 1 mole of copper being deposited. So take a minute and check the calculations. 2 by 96,500. Yes, you can. You can. So in that case, it would be 1.24123 multiplied by 10 to the power of -3 moles. Yeah, correct. Very good. Very good. So even if you are off, because remember, some people would approximate a little after or before, and your answer might vary by, let's just say 0.00123 or 125. I think 5 is pushing it. 123 or 125 is fine actually, right? If your answer varies, CXC would not penalize you, so don't be scared, right? Okay, great. So I am moving on. Calculate the mass of copper that would be formed. And I just wanted to point something out. Notice that we have to use this answer to get this answer. So we have to be on our toes from the beginning, right? So, um, calculate the mass of copper that would be formed. Relative atomic mass of copper is 64, and that is the information that they gave us, right? So the relative atomic mass of copper is 64. We use our conversion ratio. Um, Mole is equal to mass over relative atomic mass. And we just transpose where we would take our relative atomic mass and we would carry it across the equal sign to be multiplied by mole. So mass is equal to mole multiplied by relative atomic mass. Again, we have to use this answer to calculate this answer. So if you're wrong, it's like a domino effect. If you're wrong from the first question, it's like a domino effect. You'll be losing marks. So you have to be careful with your calculations. So your number of moles is 0.00124 multiplied by 64, which is your relative atomic mass. Um, Check over the calculation, 0.00124 multiplied by 64, and you will get 0.07936. I, but had the right idea, meaning if you have the correct formulae, but you substituted the wrong numbers. Eva, do you mean that? I think they would probably, I can't say for sure, but I think they would probably either give you error carried forward or they may give you a mark for your formula and they would take off the mark for substituting and calculating, etc. Yeah? Okay. Right. So suggest a reason for the difference between the mass of copper obtained and the mass of copper recorded. So this is what I was saying. This part is important. First, wash in distilled water, dried and weighed. So they want us to find, and in an experiment, it's usually always this: the mass of the copper obtained and the mass of the copper recorded. So it's actual versus. This is where your sources of error that you have been doing in labs come in handy. So the difference in mass of copper obtained and mass recorded in the table. So we got 0.079, right? And the mass of copper recorded in table 1, which mass are they actually talking about? The mass of copper recorded, which would be your actual mass that you got. So in your calculations, you are actually calculating the theoretical value or the perfect value, the perfect mass value of copper that you should be getting according to your according to the moles of stuff that you use and Faraday's and all these different things, right? But there is always a difference between your theoretical and your experimental, simply because no experiment is perfect. You always have some source of error along the way that allows you to get slightly imperfect results. So, a reason for this, the cathode was not dried completely, right? And if you are washing it with distilled water and you have not dried the cathode properly, then you will have elements of water left back in your cathode. And that will result in water of crystallization, or that will result in a either it will result in a higher mass, right? And another, so they say suggest a reason, but I put two reasons. Another reason would be impurities present in the electrolyte. So remember, in your electrolyte, you are supposed to have just copper sulfate, but well, copper 2 plus ions and sulfate ions. But if you have any impurities present, it means that there is a chance for these impurities to actually be deposited onto the cathode. You all understand that? So the current could be passing through this solution. The current could be passing through the electrolyte, breaking up the copper sulfate into copper 2 plus ions and SO4 2 minus ions. And then whatever impurities are left, it is possible for the impurities to be, depending on the impurities, it is possible for the impurities to be deposited on the cathode. Is that okay for everybody? Okay. Let's go to some qualitative analysis. If you have any questions, from the electrolysis part, or you have any concerns, you can let me know. I'll always go back to it, right? So let's go to the qualitative analysis. Complete table 2 by writing observations for each test carried out on salt S. A sample of salt S is heated strongly in a dry test tube. Moist red and blue litmus is held at the mouth of the test tube, right? So we were required to fill out the observations, right? So let's pay attention to the inference. An acidic gas was produced. Look at the tests that they are doing. Moist red and blue litmus is held at the mouth of the test tube. If it's an acidic gas, then it will turn blue litmus red, and it will have no effect on the red litmus. Nitrate ions are present. You also have to pay attention to the sample of salt being heated. If the sample of salt is being heated, then a gas would be produced. So if nitrate ions are present, then the gas that is being produced would be nitrogen dioxide, which would be a brown gas being produced. Next test. To an aqueous solution of salt S, aqueous sodium hydroxide is added gradually in excess. So with zinc ions being confirmed, we would see, or we would observe that a white precipitate, which is soluble in excess, sodium hydroxide, would be in your test tube, right? So for zinc ions, a white precipitate soluble in excess, sodium hydroxide would be visible, right? This is just as the years of chemistry went by, they started testing qualitative analysis less and less. But they did it last year, so who knows what they would do this year. So that was the first question. So let's go to the second question now. It seems as though this is acids and bases. Okay, phosphoric acid, or H3PO4, is a common additive in most soft drinks. It reacts with sodium hydroxide, which is an alkali. While I'm reading, can somebody just put the definition of alkali in the chat? Phosphoric acid, H3PO4, is a common additive in most soft drinks. It reacts with sodium hydroxide, which is an alkali, to form both normal and acid salts. Define each of the following terms. Acid. Acid is a substance when dissolved in water produces H plus ions in solution, right? An acid is a substance when dissolved in water produces H plus ions. So an alkali is a soluble base, a base being the oxide or hydroxide of a metal. So remember, you have the general category of bases, and under bases, you have alkalis. So an alkali is a type of base, but it's the type of base that is soluble in water. Bases are insoluble in water. So you have two categories, bases and you have alkalis. Your bases are insoluble in water and your alkalis are soluble in water. So we also have to give the definition of a normal salt. A normal salt is formed when all H plus ions of an acid is replaced by a metal cation or ammonium ion. This is supposed to be O. So anybody could tell me the definition of an acid salt? Here we have the definition of a normal salt. But what is the definition of an acid salt? Because usually in some instances, they ask for the definition of acid salts. Anybody could give me that? Yes, no? Excellent. So, an acid salt is formed when only some of the hydrogen ions in an acid are replaced by a metal or ammonium ions. So, key difference for a normal salt and an acid salt. For a normal salt, all the H plus ions are replaced, and an acid salt, only some are replaced. Thank you very much, Lani. So, for part B, write a balanced equation including state symbols to show the formation of the normal salt formed from the reaction between phosphoric acid and sodium hydroxide. So, formula for sodium hydroxide NaOH plus H3PO4, forward arrow, you're going to get sodium phosphate. So, normal salt, they put in bold, meaning that phosphoric acid is a tribasic acid, so it has three hydrogens. So this sodium metal is going to replace all three hydrogens, resulting in Na3PO4 and water, a neutralization reaction. So NaOH, we have one sodium on this side and three sodiums on this side. So therefore we need to balance. So while balancing, we ended up with three sodium hydroxides and three waters. So three, can you all check the balancing of this equation and let me know? You can put a thumbs up if you think it's okay in the chat. Okay, excellent. Very good. Let's go with C part 1. State the molecular formula for an acid salt from the reaction between phosphoric acid and sodium hydroxide. So in this question, they ask you for an acid salt. And if we remember the definition that Lani gave, an acid salt is only when some hydrogen ions are replaced. So I gave you two examples where we only replaced one hydrogen from the phosphoric acid, and when we replaced two hydrogens from the phosphoric acid. So it became NaH2PO4, and then it became Na2HPO4. So they only ask for one, so you can choose one and you can use it accordingly. All right? Now they are asking for a balanced equation to show the formation of an acid salt stated in C, part 1. So NaOH aqueous plus phosphoric acid aqueous to give you NaH2. So I used this one where I was only replacing one hydrogen. So NaH2PO4 plus H2O liquid, right? So always remember to put your, whether they ask you or not to put your state symbols, always put your state symbols because it is very important, right? It gives the gives the chemical equation a sense of completion, right? So is this balanced? Anybody could tell me if this is balanced? Okay, good. Right, let's go with part D now. A solution of 0.05 molar phosphoric acid has a pH of 4. So let me underline my keywords. pH of 4, while a solution of same concentration, 0.05 molar, 0.05 molar, has a pH of 4, while 0.05 molar sulfuric acid has a pH of 1. So you would realize that both of these concentrations are the same but vary in pH. State which of the two acids is stronger. According to the pH table, the closer to zero you are, the stronger the acid you are. The closer to 7, the weaker. So the obvious choice here would be sulfuric acid being the stronger acid since it has a lower pH. This was an easy 1 mark question. Right, so let's go to E part 1. Jeffrey complains of pains due to excess stomach acid after consuming too much orange juice. Name two acids present in orange juice. We have the obvious choice, citric acid. We know citric acid to be present in all citrus fruits, and ascorbic acid, or what we would commonly known as vitamin C. So any fruit you know that has vitamin C, you can put ascorbic acid as the acid being present, and your citrus fruits you put citric acid, right? State the type of chemical reaction that takes place in the treatment of excess stomach acid. We know this would be a neutralization because when we want to treat stomach acid, we would use an antacid, which usually consists of magnesium carbonate. So a carbonate and an acid, if you want both of these things to react, you call it a neutralization reaction, right? You will get your salt and you will get water. State the chemical name or formula of one compound that can be used to treat excess stomach acid. You have an antacid, which is what I just mentioned, calcium carbonate being one, magnesium hydroxide, and aluminum hydroxide. So that was 15 marks. And the first question being 25 marks. So I think those questions were doable, more than doable. So here we're going into organic chemistry. A personal favorite. Anybody here likes organic chemistry? Or you all prefer the principles of chemistry parts of the syllabus? I think organic chemistry is very straightforward. Yes, organic chemistry is it. It really is that girl. So, um, state two natural sources of hydrocarbon. We could use petroleum or crude oil, or we could use coal or natural gas. Anything you want to put, you can put it. Anything you remember first in the exam. State two natural sources of hydrocarbon, petroleum or crude oil, and coal or natural gas. Part B. Identify the process used in the oil and gas industry to separate the components found in a natural source of hydrocarbon. So we have fractional distillation. Fractional distillation is the separation method or the separation technique that you use to separate your petroleum, crude oil into its separate components to make it more useful or to pull out the different components or the different fractions to use it for different things. So let's look at the fractions. Name two fractions that are obtained from the process of separating the components found in natural sources of hydrocarbon. State the use of each fraction. So, for fraction 1, we have refinery gas, and refinery gas can be used for cooking. Um, Another fraction, they didn't say fraction 2 as in the fraction after fraction 1, eh? They say name any two fractions. So fraction 2, I decided to use bitumen, and bitumen is an additive used to pave roads, right? Very, very popular question. So let's go to part D. Methane and propene. So you have an alkane and an alkene are obtained from the separation of hydrocarbons and both react with bromine. Write a balanced equation for the complete reaction of methane and bromine. So methane is a light hydrocarbon. The light hydrocarbons would be in the gaseous state in at room temperature. So methane being CH4 gas, add Br2 liquid, you are adding bromine to it, and you would end up getting, so your bromine would replace one of the hydrogen. Now, this is not the final reaction, eh? Remember the radical reactions that we did during the during reactions of alkenes. So what I did here was just the first reaction where one of the bromine atoms would replace only one of the hydrogen in your CH4 molecule. So you can have further to this, you can have CH4 plus Br2 forward arrow, you can replace two of the hydrogens. So it would be CH2Br2 plus HBr. So you can have any of that. And of course, you would just have to balance it after, right? Until you can go straight down until you um substitute all of the hydrogens in your methane molecule, right? Remember to put in your state symbols. Let's go with part two. Write a balanced equation, including state symbols. So notice that they didn't put state symbols here and they put state symbols here, but still included just in case because you don't want to lose marks easily. So write a balanced equation including state symbols for the reaction of propene and bromine. So propene is C3H6 gas plus Br2 liquid, forward arrow C3H6Br2. Right? This is simply an addition reaction. So on top we would have had a substitution reaction. Below, we would have an addition reaction because here we are dealing with an alkene. Here we are dealing with an alkane. Alkanes are characteristic of substitution reactions. Alkenes are characteristic of addition reactions as we add across the double bond. Good? Right. Pentene can exist as isomers. Draw the fully displayed structures of two isomers of pentene. So luckily for us, they gave us an alkene. And with the alkene and its isomers, we can simply shift the double bond. So we can have the double bond placed in the first between the first and the second carbon in one isomer, and in another, we can just shift it to either the second or the third carbons. So that is exactly what I did. I have my double bond in the first between the first and second carbons, and then in the second isomer, I have my double bond placed between my second and my third carbons. And this is perfectly acceptable. This is right. This is what we should do. Any questions so far? We did electrolysis. We did organic chemistry, and we did acids and bases and salts. Now we're going to do bonding. Any questions so far? Put a thumbs up if you're all okay. Very good. Thank you. Thank you. Okay, so let's go to question 4. Element X is found in group 2 of the periodic table. Group 2 is metals or non-metals. Anybody could tell me? Metals. Very good. So element X is found in group 2 of the periodic table and reacts with chlorine to form a chloride. Describe the type of bonds found in each of the following. So in element X, we would have metallic bonding because in group 2, we have metals being present. So metallic bonding, simple and straightforward. Positive metal ions, or what we call cations, are held together by a sea of mobile electrons. And this is perfectly acceptable. For part 2, the chloride of element X. So element X is a metal. The chloride ion, metal or non-metal? Chloride is group 7. Metal or non-metal? Non-metal. Great. So when we take a metal and try to bond it with a non-metal, we get ionic bonding. So we have to describe that now. Ionic bonding is the transfer of electrons from a metal to a non-metal. Positive metal ions electrostatically bonded to negative chloride ions. Right? Simple and straightforward. So part B, we have they ask us to write a balanced equation, including state symbols, to show the formation of the chloride of element X. Now, you cannot go and you cannot take a random metal from the periodic table and react it for them with chlorine. They are asking you specifically for element X. So, therefore, we will give them element X. We will take X solid plus Cl2 gas forward arrow X Cl2 because X is in group 2. So therefore it will bear a 2 positive charge. Chlorine is in group 7, so therefore it will bear a negative charge. So therefore we can do the crisscross rule and we would get XCl2 solid, right? So solid, gas, and solid. Right. So part C. Calculate the relative atomic mass of element X. Given that the molar mass of the chloride of element X is equal to 159, so they gave you that the entire chloride of X is equal to 159. So when we are finding relative atomic mass, we will take each atom and add it together. So it will be X plus 2 chlorine atoms. So X is what we want to find. So we need to keep that in mind. Chlorine, they gave us is 35.5. So we have 2 chlorine atoms, 2 multiplied by 35.5, which would give you the 71. You transpose or make X the subject of the formula. So it would be 159 minus 71 to give you 88 gram per mole. Everybody okay with that? So for part D, we have element X also reacts with oxygen. Write the formula for the oxide formed. Excuse me. Element X is in group 2, so it bears 2 positive charge. And if it's reacting with oxygen, oxygen is 2 minus. We have our charges already balanced here, so therefore it will take one X atom to react with one oxygen atom to get the oxide of the metal. Good? Okay, moving on. Right, so we have, I think, yes, this was 6 marks. The bonding of various substances can account for the properties they display. Graphite is used as an inert electrode. Inert means that you are not taking part in the reaction, whereas element X is not likely to be used as an inert electrode. So, in some ways, element X would be reactive and graphite would be relatively unreactive. With reference to the bonding in graphite and element X, explain why graphite is used as an inert electrode while element X is not. So let's look at graphite first. Graphite. In graphite, carbon is bonded to 3 other carbon atoms in layers of hexagonal rings. Recall that carbon is pentavalent. So pentavalent means that it has 4 electrons in its outer shell. Carbon, I'm just drawing the outer electrons, right? So recall that carbon is pentavalent, which means that it only has four bonding electrons, right? Since only three, so if this three are occupied, these three are only occupied, you have this one to roam free, to be delocalized or to be mobile. And this is the reason why graphite is the only nonmetal that can conduct electricity, because you have this free electron to roam wherever it wants to go. It's referred to as being delocalized, being mobile, being free electrons. So, since only three bonds are occupied, there is one electron for every carbon that is free and mobile or delocalized. This allows graphite to conduct electricity because we know the definition of electricity is the movement of electrons, even though there are weak forces between the hexagonal layers. So you have one layer, hexagonal layer here, one hexagonal layer here, and one hexagonal layer. And there are free electrons in each hexagonal layer. These free electrons are what cause graphite to conduct electricity. But between the layers, there is a weak electrostatic force of attraction. Even though we have these weak forces, graphite is still considered stable. And because of this stability that we talk about, it means that it can be used as an inert electrode. So, to be an inert electrode, you have to be relatively unreactive and you also have to be able to conduct electricity. So, even though we have these weak forces between the layers, don't get it mixed up. You can, graphite is still stable, but because of the free electrons, it can conduct electricity. So in elements, so we did graphite. Now let's go to element X. They said that element X is not likely to be used as an inert electrode. So if it's not likely to be used as an inert electrode, then it means that element X is likely to be unstable. So in element X, we have metallic bonding, which is positive metal ions, surrounded by a sea of mobile electrons, making X a conductor. Element X is reactive and therefore cannot be used as an inert electrode. So element X has two electrons in its outer shell. So it means that these two electrons can now they are referred to as bonding electrons. So these bonding electrons cause element X to be unstable because it's ready to bond at any point in time. So because these electrons are ready to bond at any point in time, it makes element X very unstable and it would not be considered an inert electrode. Everybody understand that? Give me a thumbs up. And that explanation is exactly what I wrote there. Very good. In element X, we have metallic bonding, which is positive metal ions, surrounded by a sea of mobile electrons, making X a conductor. Element X is reactive and therefore cannot be used as an inert electrode. Right, so we have that. Oh, another organic. So this is not surprising. Every single paper, I hope they don't change it this year, considering what happened with math. I really hope they don't change it. Meaning, I hope they continue to bring the two organic questions that they bring every single year. So let's just hope for the best, right? Organic compounds A, B, C, and D belong to different homologous series. The molecular formulae of these compounds are shown below. So for compound A, we have C4H8. So somebody take compound A in the chat and tell me what homologous series does compound A belong? Compound B, C4H10. Another person, take compound B and tell me what homologous series does compound B belong? Compound C, C4H8O2. What is compound C and what is compound D? So tell me quickly. What is compound A? What is compound B? What homologous series? Is it an alkane, an alkene, an alcohol, or a carboxylic acid? Very good, Lani. So Lani gave me A and B. What is C and D? What is C? What is D? C and D could be a choice of two different things. It can either be acid or it can either be an alcohol. Which one is which? Anybody? C being an alcohol, I think C is an acid. Let me just check it. So we can draw it out to check it. C4 1, 2, 3, 4, 5, 6, 7 O and then OH. Let's see if we have 8 H's. 1, 2, 3, 4, 5, 6, 7, 8. So we have compound C being our acid and compound D, C4, H1, 2, 3, 4, 5, 6, 7, 8, 9, and our 10th hydrogen. We have one oxygen. So H, 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 H. Very good. So C is acid and D is alcohol. So, and if we are getting trouble to notice these things, we can draw it out, or an easy way is this compound has two oxygens. And if you realize you have two oxygens in your acid, so that should have been an indicator, and you have one oxygen in your alcohol. That should have been another indicator, right? Unless you have a diol, which probably isn't the case. So, 5 part A. State 4 characteristics of a homologous series. So, we have a lot of different characteristics. These are the ones that I just chose. So we have the same general formula in all homologous series, same functional group. Um, each compound differs by a CH2 group and they have similar chemical properties. They have similar chemical properties because they have the same functional group. The chemical properties of the hydrocarbons, they depend on the functional group. The chemical properties of the hydrocarbons depend on the functional group. So if they have the same functional group, then they will have similar chemical properties, right? Notice I didn't say same because they will get heavier and heavier as we add more carbons to it, right? And therefore it will differ a little bit. So part B. Compound D is often used in industry to form polyesters, and polyesters is very popular in the manufacture of clothing. So we are given the task to state two uses of polyesters. So first use the manufacture of clothing, second use the manufacture of plastic bottles, right? Part C, identify a test that can be used to distinguish between compound A and compound B. In your answer, include the expected observation or observations for each compound. So remember, as Lani would have mentioned, A is an alkene and B is an alkene. So what we would do for the test, we would add bromine water. Very, very popular test alongside acidified potassium permanganate. So we can add bromine water, and with A being your alkene, A would turn from brown to colorless, and with B, your alkene, you would have no reaction. So what you would do, you would put a sample of A and a sample of B in your test tube. Then you would add your bromine water. Adding your bromine water, these would be your observations, right? From brown to colorless with your alkene and no color change with your alkene. From the list of compounds A, B, and C, A, B, C, and D on page 18, identify and draw the fully displayed structural formulae of the alkene and the acid. So we said that the alkene was a C4H8. 1, 2, 3, 4. I put a double bond in the first spot. 1, 2, 3, 4, 5, 6, 7, 8. When you are drawing hydrocarbons, you always have to ensure that you have 4 bonds around each carbon. So we have 1, 2, 3, 4 bonds around the first carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Earlier, I would have mentioned that carbon, while we were doing the graphite question, I would have mentioned that carbon is pentavalent. Carbon cannot have 5 bonds. Carbon could have 3 bonds, but you would have a free electrons, as in you would have a free electron, as in graphite. So 1, 2, 3, 4, 4 C's and 8 H's. Let's go to the acid. Acid was C or D. Number of oxygens is 2 here, so it's C, right? So it's C4H8O2. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 2 O's. Everybody okay with that? They also asked us to name it. They said that your double bond is in the first place, so therefore it would be one butene. You have an acid which is butanoic acid because you have one, two, three, four carbons. And if you remember the table and the process of naming hydrocarbons, four carbons would be bute. The prefix would be bute. Right, so moving forward, that's 15 marks. Question 6. And after the end of each paper, we will get a small break, 5 or 10 minutes, right? So, question 6. Define the term green chemistry. So, green chemistry is something they would have recently added to the syllabus. So, green chemistry, by definition, is the design of of chemical products and processes that reduce or eliminate the use and generation of hazardous materials. So, green chemistry, in a nutshell, is everything that is good for the environment. So, principles of green chemistry, you would have had, I think, 12 principles being listed in the syllabus. So list two principles of green chemistry. First one is prevent waste. Next one, maximize atom economy. Right? You just have to learn off the definition, learn off the principles of green chemistry. Let's look at part B. A chemical factory produces pesticides, plastics, and fertilizers. So let me underline that one time. Pesticides, plastics, and fertilizers. Using synthetic raw materials. The factory, which has been in operation for the past 5 years, is located near agricultural lands. Residents of the community near the factory have reported significant environmental effects from pollution which has impacted the local agricultural economy. After bringing these concerns to the attention of the factory management, steps were taken to employ green chemistry principles to reduce these impacts. So, part one, state two examples of air pollutants which could have been emitted by the factory. So, we have pesticides, we have plastics, and we have fertilizers. So, things that cause acid rain, your NOx and your SOx. I'm not sure if you all would have heard of that. But NOx and SOx, they are your oxides of nitrogen, your oxides of sulfur. These two things would cause acid rain and would come from fertilizers and maybe pesticides. Um, HCl would come from plastics, right? So when you are burning these things, it would produce different pollutants, different materials that you are burning would produce different air pollutants that would be emitted by the factory. So these are just some examples that you can use. Suggest three substances found in the products produced by the chemical factory that may have polluted the waterways. So we have nitrates, which would be in the waterways, um, from the fertilizers. You are putting the fertilizers in the plants, and it can be run off into nearby rivers and waterways and cause eutrophication. You'll ever passing by a river and see the top layer of the river completely green with algae. So this is an indication that there is farming happening nearby, where the farmer would use the fertilizers, the excess fertilizers would run off into the waterways and cause eutrophication, right? We have pesticide residue, microplastics plastics, from the manufacture of plastics, and we can have CFCs as well. CFC would come from the plastics, right? So these are just things that we should know. Part C. Clean air in the Earth's atmosphere is made up of approximately 21% oxygen. Oxygen gas can be prepared in the laboratory. So oxygen, when you are collecting oxygen in the lab, you have to do downward delivery. So draw a label diagram of the apparatus that can be used for the laboratory preparation of oxygen. Ensure that your diagram clearly shows the location of the reagents to be used and the collection of the collection area of the oxygen gas. So that was clearly pointed out. The reaction is going on inside here. You have your tube collecting your gas, then it goes into the water, and then your gas is collected via downward delivery. Everybody okay with that? Please show me. We have finished our first past paper, so please show me a thumbs up if everybody's okay with the first past paper. Are you all sleeping? Are you all writing? What is going on? Right? So right now we would have a 10-minute break where you can get up, go and get something to eat, stretch your legs, exercise your back a little bit because it's unhealthy for us to be sitting for so long. So we're gonna take a 10 minutes break. We'll come back at now is 1:35. We'll come back at 1:45. So see you all then. Okay, great. So let's start with this question. Sodium thiosulfate solution reacts with dilute hydrochloric acid to produce sodium chloride solution. Sulfur dioxide gas, solid sulfur, and water. So here we have a chemical reaction. Sodium thiosulfate, Na2S2O3, hydrochloric acid to produce, so we are adding both of them to produce sodium chloride solution, sulfur dioxide gas, solid sulfur, and water. To investigate the effect of temperature on the rate of reaction, Paul performed different experiments using sodium thiosulfate and dilute hydrochloric acid. For each experiment, the same volume and concentration of sodium thiosulfate and dilute hydrochloric acid were reacted, but at different temperatures. So we are keeping the volume and concentration constant, but we are varying the temperature. So different, same volume and concentration at different temperatures. The temperature was measured at the start of each experiment, and the thermometer readings for experiments 3 to 7 are shown in figure 1. So experiment 3, experiment 4, experiment 5, 6, and 7. Below, they will ask us to read the thermometer and fill out your readings, which clearly got into different columns by mistake, but we'll fix that. Define the term rate of reaction. Rate of reaction is a measure of the change in concentration of a product or reactant per unit time. So rate of the reaction is basically the time that the reaction takes to be completed, right? So again, the time the reaction takes to be completed, or the rate measuring the change in concentration of a product or reactant per unit time. Easy one, mark. So remember above, they gave us the reactants and then they also gave us the products. So write a balanced chemical equation for the reaction between sodium thiosulfate and dilute hydrochloric acid. Thiosulfate, Na2S2O3 aqueous plus 2HCl aqueous, forward arrow, solid sulfur, S solid, plus SO2 gas, plus H2O liquid, plus NaCl. So let's just check to see if those are correct. We have sodium chloride solution, sulfur dioxide gas, solid sulfur, and water. So can someone check to see if this equation is all balanced out? I have two sodium chlorides, two HCl's, and one of everything else. Check and see. And let me know in the chat. Okay, good. Excellent. Part 2. Describe a test and state the observation that can be used to confirm the presence of the sulfur dioxide gas produced from the reaction. Sulfur dioxide, as we know, is an acidic gas. So it's an acidic gas. Sulfur dioxide being an acidic gas, we can test it with moist blue litmus paper. And the observation would be the blue litmus paper turning red, as we would have done in the previous paper, if you all remember correctly. So for part 3, determine the mass of sulfur dioxide produced when 50 cm cube of the gas was collected at STP, standard temperature and pressure. The relative atomic mass is something that we can calculate, and they gave us the REM of sulfur and oxygen. So we have 50 cm cube being the volume of the gas that was collected. So we want to find the mass. So we first have to find the mole, and then we will use the conversion ratio to convert moles to mass. So we have this formula, mole is equal to volume over STP. Volume being the 50 cm cube and STP being standard temperature and pressure, which is what they would have given us here. So sometimes they would give you in dm cube, sometimes they would give you in cm cube. In this case, they gave us in cm cube. So STP, 22,400. So you will take your 50 cm cube and divide it by 22,400 to get 0.00223. So somebody confirm that for me. 50 divided by 22,400, 0.00223. So confirm that for me. Yes, that's correct. If you want to write it in standard form. Or 2.23 by 10 to the power of negative 3. Very good. And the second part of this working would to take this mole and convert it to mass. So we use the conversion ratio, mole equal to mass over relative atomic mass, which is what we started off calculating here. So if we were to transpose, we bring relative atomic mass to be multiplied by your mole, you would get mass equal to mole or multiplied by relative atomic mass. You would get 0.00223 moles multiplied by 64 gram per mole, and you will end up with 0.143. Again, check your calculations. 0.143 grams. 0.00223 multiplied by 64. Everything okay? Good. So let me just state that there was a little error, probably while saving the document. So this would be 0.025, 1 over time, 0.042. Let me 0.025, 1 divided by 24. 0.042. 0.042. Y'all could go ahead and divide it before me. One divided by 15, 0.067. One divided by 11, 0.09. Ah, one divided by 10, 0.1. So confirm these figures for me, guys. 0.025, 0.042, 0.067, 0.09, and 0.1. 91. Very good. And the temperatures we would have taken from the thermometer. So this would be 14, 20, 1, 2. What did I have for this one? The second one, 20.5, because this is 21. So 20.1, 20.2, 21 minus 20 divided by 1, 2, 3, 4. Mm-hmm. So 0.25, 0.25. Let me just recalculate that. 1 divided by 1, 2, 1, 2, 4, sorry, 5, 0 0.2. So 0 0.2, 0 0.2, 0 0.2. So this would have been 0 0.4, 20.4, and 20.5, right? So this one is 14, this one is 20.5, 27, 33, and 35.2.4.5, 35.5. So 14, 20.5, 27, 33, 35.5. Good. Calculated three decimal places the rate of reaction for each of the experiment given that the rate is 1 over time. So that's how we would have calculated these values here, right? We would have just taken 1 and put it over each of these time figures. So let's go to drawing the graph. I would have already plotted the point. So it seems as though it's a best fit. I can't draw it properly on the computer screen. But it goes like this. Of course, it have to be straighter than that. Of course, it have to be straighter than that. But what I'm trying to say is that this would be the general shape of the curve that you are trying to get. The curve of rate of reaction versus temperature for sodium thiosulfate and sodium hydroxide. Right? Right. Part 2. Using the graph you plotted on page 7, explain how the change in temperature affects the rate of the reaction between sodium thiosulfate and hydrochloric acid. So we have to understand that we have a curve that is increasing in gradient. So it has a positive gradient. Your curve is sloping upwards. So therefore, it will indicate that it has an increasing relationship. So increasing curve shows that as temperature increases, the rate of reaction also increases. So as your temperature increases, so does your rate of reaction, which is how we would calculate the slope of a graph, right? Simple and straightforward. CX, only looking for two different things. As your temperature increases, your rate of reaction also increases. And throwing in increasing curve would show them that you are actually taking the shape of the graph and relating it to the relationship between the two variables of the y-axis and the x-axis. So that was your 25 marks. In June 2024, you did not get any qualitative analysis. And that is interesting because in 2025 you did. Number 2, the most stable form of the element oxygen has a mass number of 16 and an atomic number of 8. It can also exist as a radioactive isotope. So define the following terms. Atomic number. Atomic number is the number of protons in the nucleus of an atom. Mass number. Mass number is the sum total of protons and neutrons in the nucleus of an atom. Isotope. Isotopes of an atom are elements of the same atom containing the same number of protons. So your proton number stays the same and your neutron number differs. So your number of neutrons, I needed to complete this word. Your number of neutrons are different. So moving on, those are just straight and simple definitions. Part B. Use a dot and cross diagram to show the bonding present in oxygen. So oxygen is in group 6. So because oxygen is in group 6, oxygen would have 6 outer electrons. So if we're looking at the atom with the crosses, 1, 2, 3, 4, 5, 6. We have this shared space in the middle here. So therefore, the electrons that need to be shared are going in the shared space. So 1, 2, 3, 4, 5, 6. And of course, you count the dots as well. Because within the shared space, the both oxygen atoms are sharing custody of the electrons. So these 4 electrons belong to this atom, and these 4 electrons also belong to this atom. So your dots are 1, 2, 3, 4, 5, 6, and then 7, 8. Everybody okay with that? I actually drew, we're not supposed to have this electron here. So that needs to be removed because if you count it, it will be 10. And you only need to have 2 pairs of electrons here. So when you are drawing it, remove these 2 electrons. That was done in error. So part C, there are many uses of radioactive isotopes in everyday life. List any 3 uses of radioactive isotopes. I put it down here by mistake, right? Tracers, carbon dating, and nuclear power plants as a power source. Tracers, I can write it here. Tracers, what was the next one? Carbon dating. Pacemakers as well. Very good, Natalia. Pacemakers as well. Carbon dating, and I will put pacemakers. So tracers, carbon dating, and pacemakers. Very good. Down here, carbon burns completely in excess oxygen to produce carbon dioxide. So let me write that equation for you. Carbon solid, and you are burning it in carbon dioxide gas. Sorry, burning it in oxygen gas to produce carbon dioxide gas. Write a balanced chemical equation including state symbols. So 1 carbon, 2 oxygens, 1 carbon, 2 oxygens, everything balanced off. And your state symbols would be solid, gas, and then gas again, right? Carbon burns in limited oxygen supply to produce carbon monoxide. So carbon solid plus O2 gas, of course it's limited. Carbon monoxide. Anybody know the chemical formula for carbon monoxide? Can you all tell me? CO. Very good. So it's a big gas. So it's not balanced. So what you can do is put a 2 here, 2 C's, 2 O's, and you put a 2 here to get your carbon monoxide, right? So 2 carbons plus 2 oxygens, 2 carbon monoxide. Very good. Let's go again. That's 15 marks. Ah, the infamous organic chemistry. Compounds A and B are straight chain hydrocarbons whose molecular formulas are C5H12 and C6H14 respectively. As with the previous year, state one natural source of hydrocarbons. So it could be petroleum or crude oil. Um, we would have had to state two in the previous paper. So you're all seeing how things repeating is only so much they can test you for organic chemistry. So they ask us to state two natural sources of hydrocarbon, petroleum or crude oil, and coal or natural gas. Right here they ask us for one, so I use petroleum or crude oil. State two uses of compound B. Both of them are actually alkanes. One is pentane and one is hexane. So two uses of compound B. Compound B is hexane. Hexane can be used as a degreaser or it can be used to extract oils from seeds. So uses of hexane, it can be used as a degreaser or it's used to extract oils from seeds, right? Draw the fully displayed structure of compound A. A is pentane. 1, 2, 3, 4, 5. So we have 5 carbons. C5H12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have our 2 marks there. Ensure that the number of carbons is equal to the number of hydrogens in your chemical formula. C5H12, 12 hydrogens and 5 carbons. At this point, my pen was given trouble, so I opted for a picture. Draw the fully displayed structure of compound B. Compound B is hexane. C6. 1, 2, 3, 4, 5, 6. C6H2N plus 2. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So again, make sure everything lines up properly. Any questions so far? Everything okay? Right. Very good. See part 1. List any 4 general characteristics of a homologous series. So you have a whole entire list. Yet again, they are repeating. I believe we would have had to do it somewhere here. Somewhere. Or probably in the other paper. Yes, in 2023 we would have had to do it. So list any 4 general characteristics of a homologous series. homologous series have the same general formula: CN H2n plus 2, CnH2n, CnH2n plus 1, COOH, CnH2n plus 1, OH, right? So same general formula, same functional group. They all differ by a CH2 group and they all have similar chemical properties. So again, your functional group is determined, your chemical property, sorry, is determined by your functional group. You have two completely different functional groups. You have completely different chemical properties, right? So, deduce the homologous series to which compounds A and B belong. A and B belong to the alkanes group of homologous series. Um, we would have figured that out from drawing it here. Only single bonds, so therefore we have an alkane. Compound B, which is C6H14, burns completely in oxygen to produce carbon dioxide. So this is what we would call a combustion reaction. Compound B burns completely in oxygen to produce carbon dioxide and water. Write a balanced chemical equation including state symbols for this reaction. So here I have the complete balanced equation for you guys. C6H14 liquid, add O2 gas, and not taken into consideration this as yet. CO2 gas and H2O liquid. So we have six H's here. So we would need to put a 6 in front of the carbon one time. And that will give us 6 twos are 12 oxygens. And then we have 13 here. We have 14 H's on this side. So we would need to put a 7 in front of the H here. Everybody understanding what I'm doing, or you all want me to rewrite the equation? Let me know in the chat. Okay. So we have 14 H's here. So I would put a 7 in front of the H2 to make 7 twos of 14 H's, right? So that's how I would get my 14 H's. Um, I also need to consider I added an additional 7 oxygens. So I end up with 6 twos are 12 oxygens. 12 plus 7 is 19. Where am I going to get 19 oxygens? So what you can do is write this fraction 19 over 2 in front of the oxygens so that when you take this 19 over 2 and you multiply it by this 2 by the oxygen, you end up with 19 oxygens. Everybody understand that? Is that okay for you all? Okay, so that is how we end up with the 19 oxygens, right? So it's not aesthetic for us to have a fraction in front of any of our chemical compounds in a chemical reaction. So what I will do now is multiply the entire equation by 2 in order to get rid of this denominator 19 over 2. So I would end up with a 2 in front here. This will be 19. 6 twos are 12. That's how I ended up with 12 here, and 7 twos are 14. 14 water molecules. So this will be my final equation. 2C6H14 liquid plus 19O2 gas Powered arrow, 12 CO2 gas plus 14 H2O. So that's it for the first organic question, right? Hmm. Right. So you probably can't see this question, but I'll read it for you. Magnesium and lead are metals often found in living things and in the environment. Explain metallic bonding in metals. So magnesium and lead are metals found in living things in the environment. Explain metallic bonding in metals. So again, we have to define metallic bondings. Metallic bonding, positive metal ions or cations held together by a sea of mobile electrons. Right? Straightforward. We got that in the last paper as well. Give the reason why metals conduct electricity in the solid form. Metals conduct electricity in the solid form as within their structure they have free delocalized electrons that would allow for the conduction of electricity. So if you realize they tested the same thing 2 years in a row, right? So they are asking why metals conduct electricity in their solid form. We have to remember the definition of electricity. The definition of electricity is the movement of mobile electrons, right? So metals, in order to conduct electricity, you need to have free delocalized electrons within your structure. So I'll read it again. Metals conduct electricity in a solid form as within their structure. As within their structure, they have free delocalized electrons that would allow for the conduction of electricity. So part 3. State any two harmful effects of lead and its compounds on living things and the environment. So lead, very, very dangerous if you have overexposure to it. It can cause brain damage, mainly in kids and pregnant women, and it can also cause stomach issues, right? So it can cause brain damage and stomach issues. All right, part B. A chemistry student conducted a series of experiments using an electrolytic cell to test the conductivity of magnesium chloride. The materials was used to set up the apparatus, and the students' observations were recorded in Table 2 below. Table 2. Materials used to set up experiments and observations. So experiment number 1, we have PVC plastic. And anybody with some good common sense can know that PVC and plastic cannot conduct electricity. So you are using it as an electrode. Your electrolyte will be dilute aqueous magnesium chloride. Your bulb will obviously not light. And observations at the electrodes, no visible reaction. So experiment number 2, graphite. Electrolyte will be dilute aqueous magnesium chloride. Your bulb will light, and the observations at the electrodes would be gases produced at the cathode and the anode. So both cathode and anode gases will be produced. Experiment number 3, you have platinum. So your electrodes used for experiment number 3 would be platinum. Your electrolyte would be solid magnesium chloride. Apologies. Solid magnesium chloride. Your bulb will not light, and the observations at the electrodes would be no visible reaction. So let's go into part 1, and quite frankly, this is giveaway marks. Let's go to part 1. Experiment 1. Explain why the bulb did not light in experiments 1 and 3. So experiment 1, PVC is plastic and not a conductor of electricity. Hence, the bulb did not light in experiment 1. Plastic has covalent bonds, right? Um, no covalent structure except graphite is known to conduct electricity. It has no free electrons. So again, PVC is plastic and not a conductor of electricity. So experiment 3, your electrolyte is solid. That is a no-no. That is an immediate no-no. Your electrolyte is solid. So magnesium chloride is an ionic compound. And in the solid state, the ions are not free to move, just like your sodium chloride crystals. If it's in the solid state, there are no free mobile electrons. None. Magnesium chloride is an ionic compound, and in the solid state, the ions are not free to move to allow the conduction of electricity. Right? No mobile ions, solid state, no conducting of electricity. So for part 2, explain why the bulb lit in experiment 2. So in experiment 2, we have graphite. We tested graphite. We did an entire explanation on graphite in the previous paper, June 2025, right? And they are asking now why the bulb lit. So if the bulb is lighting, then that means we have a conductor in our midst. So all we need to do is explain why in experiment 2, graphite is a conductor. Carbon is bonded to 3 other carbons in layers of hexagonal rings. Recall that carbon is pentavalent. Pentavalent meaning that it only has 4 bonding electrons. Since only 3 bonds are occupied, there is 1 electron for every carbon that is free and mobile or delocalized. This allows graphite to conduct electricity. So each carbon in your graphite is bonded to 3 other carbons. So therefore, you have that free bonding electron that is mobile and delocalized and roaming free all about the place. So therefore, what will happen because of that free mobile electrons, and you have layers and layers and layers of carbon in hexagonal rings, because of the free mobile electrons for each carbon, you are going to now have the ability to conduct electricity. Graphite will have the ability to conduct electricity, right? So let's look at part 3. State the process that took place in experiment 2. The process that took place is electrolysis. And electrolysis is where you have your electrodes and your electrolytes. So that should have given you some sort of indication as to what the process would be. The process that took place in experiment 2 is electrolysis. Magnesium readily reacts with oxygen in air. Write a balanced chemical equation for this reaction. So it's important to note that anytime you are reacting anything with air, or anytime CXC asks you to react anything with air, you are you are ultimately reacting it with oxygen. So they ask us to react oxygen and air. Sorry, they ask us to react magnesium with oxygen and air. So magnesium solid plus O2 gas would be 2MgO. We have to recall that Mg is Mg2 plus, oxygen is O2 minus, therefore when we're bonding it together, it's going to be MgO, because this is balancing off with this. The 2 plus is balancing off with the 2 minus. So in order to balance this equation, it becomes 2MgO because you have two O's on this side. You are also missing a 2 here. Did anybody notice that? Did anybody notice that I was missing a 2 in front there? Anybody sleeping? Okay. Lani is sleeping, or you just notice? All right. Okay, no problem. Let's go to number 5, part A, part 1. Proteins and starch are examples of natural polymers which are formed through the process. I know, I know a lot of you all would have had maths classes or maths, studying maths, because unfortunately they put maths and chemistry back to back. Unfortunately. However, I know that you all can do it. If you have been, if you are attending this marathon session, then it means that you are interested in doing good. So don't worry. I know you all will do good. So a macromolecule made up of many repeating units called monomers. That is the definition for polymer. Right? So let me just reread the question. Proteins and starch are examples of natural polymers which are formed through the process of condensation polymerization. So the definition for polymer is a macromolecule made up of many repeating units called monomers. Let's go with part 2. Define the term condensation polymerization. Polymerization by definition. So we have to know what polymerization is first in order to define condensation polymerization. Polymerization by definition is the process of combining one or two monomers to form a polymer. However, if we are to look at condensation polymerization is a type of polymerization which allows the product of a small molecule such as water to be produced. So somebody tell me, what is the other type of polymerization we have? We have condensation polymerization, and what is the other type of polymerization? Mm-hmm. Addition polymerization. Very good. So addition polymerization will take place across a double bond. Just for some extra information, addition polymerization will take place across a double bond. With condensation polymerization, you have the extraction or a small molecule just being produced out of the reaction, right? So B part one, the manufacture of ethanol makes use of the fermentation process. Define the term fermentation. The breakdown of sugars with yeast by anaerobic respiration to produce ethanol. So if we remember we have anaerobic and we have aerobic. Anaerobic respiration is without the use of oxygen. The breakdown of sugars with yeast by anaerobic respiration to produce ethanol is fermentation. Right? So if you could see according to the equation, we're not reacting it with oxygen, right? Write a balanced chemical equation including state symbols to show the process of fermentation. C6H12O6 aqueous forward arrow, and we always have to include our yeast. So C6H12O6 with the inclusion of yeast, 2C2H5OH, which is your alcohol, your ethanol to be more specific, and carbon dioxide. So 2 moles of ethanol and 2 moles of carbon dioxide. This, if you are also a bio student, you would have encountered in bio as well. Yeah, right. So draw the fully displayed structure of ethanol. Meth, eth. The prefix eth suggests that you have 2 carbons. So 2 carbons, 1, 2, 3, 4, 5, C2H5, and then you have your OH to decide. 2 easy marks. Very, very simple, right? Um, During the demonstration of the winemaking process in the school's food laboratory, a technician separated a pure sample of ethanol. However, the flask was not labeled and water was accidentally poured into the sample. Using a line diagram, draw and label the apparatus that could be set up in the chemistry laboratory to obtain pure ethanol from the contaminated sample. So fractional distillation, sorry. Actually, no, simple distillation. You are heating it. This is your water and ethanol solution. Ethanol will come out at 78 degrees Celsius, leaving the water behind. So you always have to ensure that you monitor your thermometer properly because the boiling point of ethanol is 78, water is 100 degrees Celsius. That is why you would see the ethanol vapor going up first. It will come into the condenser. The cool water in and out will condense the vapor and you will collect your ethanol here. Everybody okay with that? So that is question 5. Let's go with question 6. Alka-Seltzer and Epsom salts are common remedies used in the Caribbean. Alka-Seltzer is an antacid used to treat upset stomach, and Epsom salt is used to treat sprains and muscles. The active ingredient in Alka-Seltzer is sodium bicarbonate, and in Epsom salt is magnesium sulfate. A. Water is called the universal solvent because it dissolves many substances. Epsom salt and Alka-Seltzer work by dissolving in water. Explain why water is a good solvent. It's not only a good solvent, it's a great solvent because you have your electronegative Oxygen, electronegativity is the ability to pull electrons towards itself. So because you have the electronegative oxygen within the structure, it's going to pull the electrons closer towards itself and it's going to cause the uneven distribution of electrons. This uneven distribution of electrons is called polarity. So water is a good solvent because it's a polar solvent as it contains a more electronegative atom, which is your oxygen, in its structure, causing uneven distribution of charges. So water, many other different things as well. Water is not too reactive with anything. Water is just there. It's chill and it's polar. The main reason is because of its polarity. Because water is so polar, right? State two properties of water other than it's a good solvent. It has a high boiling point of 100 degrees Celsius and it has a high specific heat capacity, I think of 4200 joules per kilogram Kelvin, right? Part 3 states any two other compounds that dissolve in water. Now for this part, you can name any soluble salt. Remember when you did acid, bases, and salts, you would have gotten a solubility table. You can go to that solubility table mentally because it's supposed to be there somewhere in your head. Um, Go to that table and you can pick any soluble salt. The two soluble salts that I picked were calcium chloride and sodium chloride. Sodium chloride is your regular table salt. It can never fail you. Sodium chloride could never fail you, right? Continuous use of Epsom salt in water may cause hardness of water. This does not happen with Alka-Seltzer. What is the difference between Epsom salt and Alka-Seltzer? Alka-Seltzer has sodium bicarbonate and Epsom salt has magnesium sulfate. Magnesium is popularly known, to cause the hardness in water. State the type of water hardness caused by dissolving Epsom salt in water. Magnesium, the magnesium ion, is known to cause permanent hardness in water. Permanent hardness in water. I'm not sure if you have a pipe at home or by your granny's house and on the pipe you see a buildup of white, sometimes powdery substance on the pipe. I'm not sure if that is the case or if you have ever seen it, but that is what you call permanent hardness. And the water that comes out our taps and not as treated as it should be. It's not as filtered as it should be. So therefore it will contain some contaminants, it will contain some ions, and one of it being magnesium. You will know when you have an over when you have more magnesium in your water than you should have, it will cause a buildup on your pipes, which is what we refer to as permanent hardness. So part 2, explain why Epsom salt causes hardness of water. Epsom salt causes water hardness because it is chemically known as magnesium sulfate. When it dissolves in water, the compound breaks apart into free magnesium ions. Because water hardness is scientifically defined by the concentration of dissolved calcium and magnesium minerals, adding Epsom salt directly increases the water's hardness level. Right? So calcium would be temporary hardness and magnesium would be permanent hardness. So part three, explain why boiling the water will not remove the hardness caused by Epsom salt. Because magnesium sulfate is pretty stable, sorry. It's pretty stable and will not break down when heated. It will take a lot more to break down your magnesium sulfate, right? Next question. Identify two salts that cause hardness of water and can be removed. Calcium hydrogen carbonate and magnesium hydrogen carbonate. So calcium and magnesium ions, always remember if you get a hardness of water question in your exam, always remember that calcium ions and magnesium ions cause hardness in water. One is just temporary, one is permanent. When used as an antacid, Alka-Seltzer neutralizes the hydrochloric acid in the stomach. Write a balanced chemical equation including state symbols to illustrate this process. So sodium hydrogen carbonate aqueous plus HCl aqueous forward arrow, NaCl, H2O and carbonate. This is an acid carbonate reaction. Acid plus carbonate gives you salt, water, and carbon dioxide. So this is NaHCO3 aqueous plus HCl aqueous forward arrow NaCl aqueous plus H2O liquid. So you can check it and let me know if it's all balanced. hmm It seems to be all balanced. Can anybody confirm that for me? Sometimes I could make a mistake. It actually is all balanced, right? So we have come to the end of our second past paper. So we're going to get a break now, but it's not going to be 10 minutes. It's just going to be 5 minutes. So you can get up, you can take a walk, stretch your back again, and come back at, what is the time now? You can come back at 2:51 for the start of the other paper. Great. Lani, you're well paying attention and I love that. Good, Ziva. Hayden, if I pronounce your name wrong, you can let me know, right? Okay, so let's go. June 2023. Again, 6 questions. Answer all questions. Write your answers in the spaces provided. Regular instructions, right? So this seems to be a rate question. So we can see that 2025, June. Yeah, I'm doing all June papers. We can see that in 2025, we had electrolysis as our question one. In 2024, we had a rates question. And in 2023, we have yet another rates question. Good for us. Very, very good for us. Um, Considering what happened to the math paper, I want you to consider the trends that we are seeing in the papers. but I also want you to not consider it at the same time. I need you to have a vast understanding of the syllabus because clearly you don't know what they're going to bring, right? You don't know what they're going to bring. But I mean, these questions from these papers, they basically um tested more or less the entire syllabus. Yes, the format of POA and social studies. Well, I don't know, but if you heard that, then that is also something to consider. I also saw that the POB exam was also leaked, right? I saw that this morning. So, not sure what really going on with CXC these days. But something I was thinking about is the electrolysis questions. The electrolysis questions where they actually tested not being in a question one. Um, Back then they used to test it regularly, especially copper sulfate. They used to test copper sulfate a lot, right? But as of recently, I didn't see a lot of it happening. I think the last time they tested it, um, would be probably 21 or 22. Yeah, 21 or 22. We will go to those papers. We will go to 22 after. But still learn the electrolysis of the molten and aqueous compounds and learn the different equations that go with it, right? So let's go. Another rates question. Hydrogen peroxide decomposes to produce oxygen and water in the presence of potassium iodide, which is your catalyst, right? So far, so good. Hydrogen peroxide decomposes to produce oxygen and water in the presence of potassium iodide, which is your catalyst. The effect of the concentrated hydrogen peroxide on the rate of reaction was investigated, and we know rate to be um time, basically the time that the reaction takes to occur. For each experiment, the concentration of the hydrogen peroxide was changed, and the time taken for hydrogen peroxide to decompose was measured using a stop clock as shown in figure 1. So experiment 1 to experiment 5, and we have the different timings. So you could expect a graph, right? Define the term rate of reaction. The rate of reaction is the measure of the change in concentration of a product or reactant per unit time. Define the term catalyst, right? Bio students would have this in common with chem. A catalyst is a substance that increases the rate of a chemical reaction without taking part in the reaction. A catalyst provides an alternative pathway for the reaction with a lower activation energy. Anybody could tell me what the activation energy of a reaction is? Anybody could tell me? You need the activation energy for a reaction to occur. What is the activation energy of a reaction? Nobody? The activation energy of a reaction is that amount of energy that you need for the reaction to start, right? It's that amount of energy that you need to have, very good, for the reaction to start. Very good. Easy 3 marks there. Let me see if I can. Right. Good. For each experiment shown in the stop clocks in figure 1 on page 4, record in table 1 the time taken for the hydrogen peroxide to decompose. So again, we have rate of reaction 1 over time. So you take 1 and you divide it by 60 to get these values here. So I wouldn't say this is 60, I would say this is 59. So let me change it. One divided by 59. 0.017. Oh, same thing. 0.017, right? I maybe put 60 by mistake. The other one would be experiment 2 would be 40, 41, 42. 42. 1 divided by 42. 0.024. Experiment 3, I would say is 31. I have 30. Clearly something was going wrong when I was doing this. 1 divided by 31, 0.032. 25. Right, 25 is correct. 1 divided by 25, 0.040. And 20. This have to be 21 seconds. 1 divided by 21, 0.048. So recalculate these for me and let me know, or if you were calculating it while I was calculating it, let me know if you got the same answers. Okay. Okay, good. Very good. Use axes provided in figure 2 on page 7 to plot a graph of rates of reaction versus concentration. So we have the correct rates of reaction here. Let me see if I need to change any. 0.01, 0.017, 0.1, right, 17 would be here. So that one is correct. 0.15, 0.024. This 0.15. This needs to come here. 0.15, 0.024. Let me see, 0.02 minus 0.025 divided by 0.02, 0.005. 2, 3, 4, 5, 6, 7, 8. This have to move up to the eighth line. So in case you were wondering what I did, I took 0.025, taking these two for example, and then minus 0.020. So 0.025 minus 0.020, I ended up with 0.05. So what I'm trying to do, I'm trying to find the value of one small block, right? Between 0.020 and 0.025, I have 10 blocks. So if I have 10 blocks and the value of all 10 blocks here is 0.05, I will now divide it by 10. This is supposed to be 0.005. 0.05 minus 0.0. Right. I will end up with 0.0005. So one small block is 0.0005. So let me just do that again, right? What I'm trying to do is find the value of one small block, right? So I have 10 small blocks between 0.02 and 0.025. So if I subtract these two values, I will find the value of all 10 blocks. I will find the value of all 10 blocks. And if I want to find the value of one block, I will take the 0.005 and divide it by 10. So one small block would be 0.0005. And if I want to end up with 0.024, I would just have to continuously add 0.0005 until I reach 0.024, which is evidently my eighth block, right? So just a little bit of graphical technique there for you. Let's go with the other. 0.20, 0.032, 0.20. Right, so let me count now. 0.03. Somebody could count before me and tell me what block we're going up to. 1, 2, 3. Anybody get the block that we're going up to here? Which block? Is it my first, second, third, fourth, fifth, or beyond my fifth? Remember, the graphs are the easiest way to get your points, right? To get your marks. Anybody could tell me if I'm correct by putting it at the fourth block? So 0.03, add 0.0005, add 0.0005, three zeros and a 5. Continuously would end me up at my fourth block. Fourth. Yeah, that's what I have. I have my fourth block. Very good. So next one, 0.25, 0.04. Right, so I have that one good there. Last one, 0.30, 0.048. So clearly I'm wrong here. This has to come up somewhere here, but let me check. So it will be 0.045. 2, 3, 4, 5, 6, 7. I got the seventh block. So 5, 6, and 7. Right, this is my seventh block. So we end up with a nice straight line. A nice straight line. Let me check back these points. 0.20, 0, 0.032. Okay, so it's a line of best fit. Hmm. Mm-hmm. So if you could see, it's passing through this point, it's passing through this point and this point. You have this point being outside and this point being outside. So you see, you have even spread on both sides, right? Even spread on both sides. Good. Everybody agree with that? Okay, good. Using your graph. So we have to use the graph. Describe the relationship between the rate of reaction and the concentration of hydrogen peroxide. So it's a straight line, so therefore it shows linearity. Linearity suggests that you have a directly proportional relationship between your variables, states that you have as one variable increases, the other variable increases as well. So using your graph, describe the relationship between the rate of reaction and the concentration of hydrogen peroxide. So according to the shape of the graph, the rate of reaction varies linearly, meaning it has a proportional relationship. This means that as the concentration of hydrogen peroxide increases, the rate of reaction also increases at a constant rate. Graphically, this is represented by a straight line passing through or near the origin. This one probably has the ability, if we extend it a little bit, near the origin. I don't think I could see this one passing directly through the origin, right? So part two, determine the concentration of hydrogen peroxide given that the rate of reaction is 0.045. So here we would have to extrapolate. So they're asking for 0.045, so therefore we will have to extend. Let me see how best I can extend this. It's going out. 25, 31, 42, 59. Um, determine the concentration of hydrogen peroxide given that the rate of reaction is 0.045 per second. This is not going through 0.045. So we have a few things to check. Just recalculate some stuff. Two, 41, 42. This is 31. This is 25. And this is 21. I don't see anything wrong with the values for time here. Hmm, 20. Unless zero point 0.30. I really not seeing what is the problem. Concern. Concentration 0.10, 0.3, 0.048, 0.3, 0.048. And they want, oh, oh my God. I read the question wrong. So 0.045. I'm thinking 0.45. I'm so sorry, guys. I read the question wrong. So what I'm going to do, I'm going to extend it going straight back. So let me see how I can extend it. Best fit, right? And we are cooking with gas once more. So the problem, guys, I was trying to figure out is how is 0.45 is going to touch the graph when we are extrapolating. But I read the question wrong. It's 0.045. So we need to extrapolate below. So I would have extended the graph until it met the somewhere close to the origin, crossing the y-axis, right? So let's calculate. Tell me which block here is 0.045. 0.05, 2, 3. The ninth block is correct. So ninth block would be right here. Let's go straight up and across. Going straight across. So what value is that? Tell me. 0.00 what? The value for rate of reaction. 0.00. What is the last two numbers? 0.0085. Excellent. So your answer for this part would be 0.0085 mole per dm cube. The concentration of hydrogen, remember that I did solid lines when I was extrapolating, but remember that you need to do dashed lines. You need to do broken lines to show your extrapolation. And your extrapolation is part of your working, right? So the examiners would like to see how you are extrapolating in order to get that value, right? Okay, moving on. Part F. Calculate the mass of the hydrogen peroxide present in the concentration identified in E part 2. So I would have to change this to 0.0085. Um, so 0.0085. multiplied by 34.01. And what did you get? 0 point what? So what I did here, I used the conversion ratio, moles equal to mass over molar mass. And they ask us to get the mass of hydrogen peroxide present in the concentration identified. So this was the concentration we got. So moles is equal to mass over molar mass. And I made mass the subject of the formula, which is moles multiplied by molar mass. You're going to get 0.0085 mole per dm cube multiplied by 34.01. What did we get, guys? Good. 0.29 or 0.289? Yeah. 0.29 grams. Good? Good. Final question in part one. Write a balanced chemical equation, including state symbols to show the decomposition of hydrogen peroxide. Hydrogen peroxide being H2O2, um, 2H2O2 aqueous, forward arrow, 2H2O liquid, plus O2 gas. Right? Easy does it. Good. We got through. Straight line. Remember to show your arm. Remember to have an even spread of points on both sides for your best fits, for your line of best fit. And remember to show your extrapolation lines clearly. Don't put it too dark, but put it a little light, but light enough so that the examiners could see and it won't look too untidy on your paper. Right? So that's your 25 marks. Let's go to 2 part E. At atmospheric pressure, water exists in 3 states of matter, while carbon exists in only 2 states. List the 3 states of matter in which water can exist. Easy. Solid, liquid, and gas. Right? And I pray that you'll get a question as easy as this year. Describe the energy of the particles in each of the 3 states listed in A part 1. Solid. Particles have the least amount of energy and vibrate about their fixed positions. Liquid. Particles have more energy than solid, can slide past each other, but still held close together. When you are given the task to describe the energy of the particles in your different states of matter, you always need to do a comparison. Compare the amount of energy that a liquid has with a solid, and then a gas has with a liquid. They always want to see that. So particles have the least amount of energy and vibrate about their fixed positions. Liquid particles have more energy, so that is my comparison there. Particles have more energy than a solid and can slide past each other but still held close together. Gas particles have the most amount of kinetic energy, with particles moving randomly and haphazardly with negligible forces of attraction. Remember that energy of particles, don't confuse it with intermolecular forces. I've had students do that to me already. Do not confuse Energy of particles. When you're talking about energy of particles, you're talking about the kinetic energy, the way that they move. Do not confuse it with intermolecular forces, right? So particles have the most amount of kinetic energy, with particles moving randomly and haphazardly with negligible forces of attraction. Part 3. Name the process which occurs when carbon dioxide changes from one state to another. Y'all ever heard about dry ice? Y'all ever see dry ice before? Yeah. Dry ice is solid carbon dioxide. When you put dry ice out there, dry ice immediately turns to a gas. Solid turning to a gas is what we call sublimation. The change of state of a solid to a gas is called sublimation. Right? Next part. Describe how the arrangement of the carbon dioxide particles changes as carbon dioxide undergoes the process named in A part 3. In solid carbon dioxide, the molecules are closely packed in a fixed regular arrangement and only vibrate in place. During sublimation, the molecules gain enough kinetic energy to overcome the weak forces between them. They leave the lattice structure spread far apart and move freely and randomly in all directions as a gas. So in that manner, you are going straight from a solid to a gas. Notice I have all the elements of how a solid behaves, and then I went straight to all the elements of how a gas behaves. Part B. Using appropriate diagrams, illustrate the lattice structure of sodium chloride crystal and the giant molecular structure of diamond. This is graphite. How did that reach there? Diamond. Let me draw back that one. You're seeing how the bonds being interconnected. So it's really a network. It's really a network of carbon atoms in this structure networking together. That is what diamond is. For sodium chloride, you have a cube-like structure with chloride ions at the end and sodium chloride, sodium to the middle. Na, Ne, Ne. Good? This is what you would have done in structure and bonding. Let's go with part C. In solution, two metals, A and B, form A plus and B2 plus ions respectively. So immediately you can see both of them are metals. Both of them are metals, right? Metal A displaces ion from solution containing Fe2 plus ions. This is a displacement reaction, but metal B does not. Write a balanced ionic equation to show the reaction between metal A and ion 2 plus ions. So your A is starting off as a metal, meaning that it's starting off as a solid. It's going to be Fe2 plus, right? Your Fe2 plus is going from an aqueous state to a solid state. Anybody could tell me why? Can anybody tell me why? Why is ion 2 plus going from an aqueous state to a solid state? Thumbs down if you don't know. All right. They said in the question that metal A displaces Fe from a solution containing Fe2 plus ions. So if metal A is displacing your ion 2 plus ions, then it will come out of solution to become Fe solid. So because this is a displacement reaction, A is going from solid to aqueous because A is going in solution. It is taking over the state of ion. It is taking over the place of ion. And ion is coming out of solution and being deposited as ion solid. Right? So that is the reason why everybody changes states at some point in time. I don't know. I think the screen freezed. Let me just stop sharing and share it back. All right. Everybody seen the screen now? Everybody seen the screen? All right, good. Good. Let's go to the other question. Organic. Figure 3 shows the fully displayed structures of three compounds A, B, and C. We're halfway through our third paper. Figure 3 shows the fully displayed structures of three compounds, A, B, and C, which are from different homologous series. What is the homologous series of compound A, guys? Compound A. This is our third organic question. Our third intro to organic question. Alkane. What is B? Acid. What is C? Alcohol. Excellent. Very good. So figure 3 shows the displayed structures of three compounds A, B, and C, which are from different homologous series. Compound A, compound B, and compound C. State the homologous series to which compound A and B belong. So A is alkenes, B is acids. Compound C burns with a blue flame in oxygen. Write a balanced equation for this reaction. So again, you are doing combustion. Make sure you know your different combustion reaction equations. Compound C burns with a blue flame in oxygen. C2H5OH, that's your alcohol, liquid, plus 3O2 gas, forward arrow, 2CO2 gas plus 2H2O, liquid. Two C's, 5 and 1 is 6. Am I balanced, guys? So two C's, 5 and 1 is 6. 3 twos are 6. Actually, no. 2 twos are 4. Right. I was balanced before. 3 twos are 6. OH. Let me know if I'm balanced here. 5, 6. 3 twos are 6. And 1 is 7. Okay, good. Yes, we are balanced, right? So part C, state which of the two compounds A or C is more soluble in water. Give a reason for your answer. So compound C, if we look at compound C is more soluble in water. Ethanol contains a polar OH group. Remember, we were talking about polar compounds before when we were talking about water being a good solvent, right? Ethanol contains a polar OH group that allows it to form hydrogen bonds with water molecules. In contrast, pentane, which is compound A. So really and truly, you're looking at a compound that has no electronegativity in its structure compared to a compound that has electronegativity in its structure. And polarity strictly comes from compounds that has electronegativity in its structure because that pull of electron causes the uneven distribution and furthermore, that uneven distribution causes the compound to become polar. So I'll start back. Ethanol contains a polar OH group that allows it to form hydrogen bonds with water molecules. In contrast, pentane or compound A is a non-polar hydrocarbon that only experiences weak van der Waals forces and cannot form hydrogen bonds with water, making it essentially insoluble in water. So I don't know. Send a thumbs up if you ever hear this rule in chemistry. Like dissolves like. You all ever hear about that before? Like dissolves like. Right. So your polar compounds will dissolve in polar compounds. So if pentane is non-polar, it will not dissolve in water. Right? So part D. State whether compound B or compound C would react more vigorously with sodium metal and give a reason for your choice. Compound B will react more vigorously with sodium. So compound B is your acid. They are comparing your acid with your alcohol. Carboxylic acids are stronger acids than alcohols because the OH bond in so I want you all to look at this functional group, right? You can see that there is a double bond with this oxygen on top here, and there's also an oxygen at the bottom here. You all have to understand that oxygen is electronegative, and electronegativity by definition is the ability for an atom to pull electrons towards itself. So this double bond has a higher electron density because of the two bonds, meaning that it has more electron in the bonds on top here than down here, right? So there will be a push and a pull between the electrons in within this area here. Because of that, think about it as like a chaotic confusion. Because of that, this oxygen and this hydrogen now has a weak bond between each other. So let me try it like this. This oxygen and this hydrogen within the functional group of the carboxylic acid will have a weak bond and therefore it will be loosely held. So this hydrogen would be easy to lose and something else to come in here. You all understand what it is I'm saying? This hydrogen will be loosely held and therefore here will now become a reactive center, so to say, right? So carboxylic acids are, this is why carboxylic acid will be the stronger acid between the alcohol and the acid because it has the ability to bond quicker, or it has the more vulnerable reactive site than the alcohol itself, right? Because the OH bond in the COOH group breaks more easily to release H plus ions. Remember, the definition of an acid is to release H plus ions in solution. As a result, compound B reacts more rapidly and vigorously with sodium metal, producing hydrogen gas at a faster rate. Everybody understand that explanation? Okay. Write a balanced equation for the reaction of compound C with sodium metal. So compound C is your alcohol. So 2C2H5OH liquid plus 2Na solid. Forward arrow 2C2H5O Na solid plus H2 gas. Right? Your alcohol with your metal. Right? Your alcohol with your metal, you will get your, let me draw it out. C2H5OH and you are adding your sodium. This H is going to be released from the OH and therefore this sodium is now going to be attached on to the alcohol, making um C2H5ONE and hydrogen gas, right? Good. I'll leave it up there in case anybody wants to write it down. Part F. Describe one test that could be used to identify the gas that is produced in the reaction of compound C with sodium metal. So we have hydrogen gas being produced. So we can place a lighted splint over the test tube containing the gas, and the splint will extinguish with a squeaky pop. Everybody okay with that? That's just basic, that's just simple. That is your test for hydrogen gas. Good? Yeah. Part G. Compound B and compound C react together in the presence of a catalyst to form compound D. Compound B and compound C react together in the presence of a catalyst to form compound D. A acid and an alcohol, what does that gives you? Carboxylic acid and an alcohol. What does that give you? Good. Very good. It gives you an ester. This is esterification, right? So the catalyst in esterification is concentrated sulfuric acid at 170 degrees Celsius, but it didn't ask for conditions. So catalyst is concentrated sulfuric acid. Draw the fully displayed structure. So here I have the ester group, right? Here I have the ester group. This would come from the acid, and this would come from the alcohol. So this is what is happening. Let me draw it here. And you are adding your alcohol to this. Right? Your OH from your alcohol and your H from your acid is released into solution. So this is what is happening. And then your alcohol is now going to be joined to this reactive center. So it's now going to become your ester. 1, 2, 3, 4, 1, 2, 3, 4. This is now going to become your ester. Right? So that's how your ester is made. From the reaction of your ester and your, sorry, the reaction of your acid and your alcohol. Right? So we on to question 4. Sulfur and magnesium are two elements in the same period of the periodic table. The different properties of the oxides of these elements are presented in Table 2. So the oxide of sulfur is a gas and the oxide of magnesium is a solid. The melting point of the oxide of sulfur is -72 and the oxide of magnesium, the melting point is 2852. We have some clear explaining to do. With reference to bonding, explain the difference in melting point between the oxides of sulfur and magnesium. You'll see how to bring bonding again. Bonding, bonding, bonding. In the three papers that we did already. Right? Yeah. Sulfur is a non-metal. So sulfur dioxide has simple covalent molecular structure. Oxygen is already a nonmetal. Sulfur is a nonmetal. So nonmetal and nonmetal coming together to give you a covalent bond. So the structure of the oxide of sulfur, which is sulfur dioxide, is simple covalent. And we all know that if we were to compare covalent bonds with ionic bonds, we would see that covalent bonds are way weaker than ionic bonds. So sulfur is a nonmetal. So sulfur dioxide has a simple covalent molecular structure. It is made up of small molecules with strong covalent bonds within each molecule, right? But only weak intermolecular forces between the molecules. So SO2, and then you have another SO2, you have the covalent bonds are strong here. However, the intermolecular bonds, the bonds between between two molecules are weak. It is made up of small molecules with strong covalent bonds within each molecule because of atomic radii, etc. But weak intermolecular forces between the molecules. So these covalent bonds are strong, but the bonds between both molecules, and let's just say we had another sulfur dioxide here, would be weak, strong, right? Since only these weak forces need to be overcome when melting occurs, very little energy is required, giving sulfur dioxide a very low melting point of -72 degrees Celsius. Magnesium oxide, however, is an ionic compound. Because magnesium is a metal, oxygen is a non-metal. So magnesium oxide, however, is an ionic compound formed between magnesium ions and oxide ions. These ions are arranged in a giant ionic lattice and are held together by strong electrostatic forces of attraction. A large amount of energy is needed to overcome these forces, and the melting point would be 2852 degrees Celsius. So we are looking at the properties of covalent versus ionic here. We know that ionic structures, ionic lattices, are very strong and simple covalent molecular structures are weak. The intermolecular, meaning the intermolecular forces of attraction between two molecules can be weak. Is that understood? Everybody okay there? Yeah, no? Everybody sleeping? All right. Next question. Explain whether the oxides of sulfur and magnesium will conduct electricity and, if so, under what conditions? So we're talking about conduction of electricity. We're talking about movement of ions, movement of electrons. SO2 or sulfur dioxide is a covalent molecular substance and does not conduct electricity in any state because it has no free ions or delocalized electrons to carry charge. However, when sulfur dioxide dissolves in water, it forms sulfurous acid, H2SO3, which partially ionizes to produce H plus and HSO3 minus ions, allowing the solution to conduct electricity. Magnesium oxide is an ionic compound with a giant lattice structure. In the solid state, it does not conduct electricity because the ions are fixed in place. When molten or dissolved in water, the ions become free to move and are able to carry electrical charge, so it conducts electricity. So, anytime they ask you to explain why something can't or can conduct electricity, you have to think about how the ions or how the electrons are moving. Good? Part B. Figure 4 is a partial diagram of the apparatus of a group of students intend or propose to use to investigate whether ethanol, aqueous ammonia, and aqueous lead nitrate would conduct electricity. Complete the diagram in figure 4 in order to make it a circuit that is suitable for achieving the aim of the experiment. So they didn't have this beaker. I put in the beaker and I put in this ammeter. Anybody know what an ammeter is? Anybody know what an ammeter is? Anybody doing physics? An ammeter is used to measure current. Yeah. So we would want to know if any current is passing through the circuit while the electrolysis is happening. Classify the three substances to be investigated, which is ethanol, aqueous ammonia, and aqueous lead 2 nitrate, either as conductors or non-conductors. So for the conductors, we would have aqueous ammonia. It would be um a weak conductor, so to say, and aqueous lead. Lead is a metal, right? Lead is one of your metals, Pb2 plus in group 2. So in its aqueous state, it would be able to Conduct electricity. Your non-conductors would be ethanol. Ethanol is completely covalent. And that's it for question 4. You all think you would be able to get this 6 marks for this question? Or this 4 marks? 6 marks and 4 marks is a lot, eh? You all think you ought to be able to get these 6 and these 4 mark questions, correct? Yeah, no. Okay, partially. So what you can do, you can take down the answer to the questions. The video will be posted on YouTube after. Mr. Ballantyne will post it, so you can look out for it and you can go through the solutions and you can write it down and you could, you know, analyze it accordingly. Yeah? Because those marks would be real hard to lose. All right, let's look at 5A, Part 1. Define the term anaerobic fermentation. Anaerobic fermentation occurs when is used in the production of wine. Anaerobic fermentation is the breakdown of sugars, such as glucose, by yeast or other microorganisms in the absence of oxygen to produce ethanol and carbon dioxide. Excuse me. So within the definition itself, you have the products of the reaction that you will get, right? Part 2. State one reason why high temperatures are not suitable for anaerobic fermentation. So you have enzymes. This is bio. You have enzymes in your anaerobic fermentation. High temperatures will denature these enzymes, resulting in a stop in the conversion of glucose to ethanol, which in fact is fermentation. So it will stop your fermentation because you have no enzymes. Part 3, write a balanced equation for the anaerobic fermentation of glucose. So C6H12O6, C2H5OH because you are getting ethanol, and CO2, carbon dioxide, ethanol and carbon dioxide. And you can put a little yeast on top there. All right? On top your arrow. Part B. Soaps are formed from the alkaline hydrolysis or saponification of natural oils and fats or esters. Compound E shown below is an ester which is hydrolyzed by aqueous sodium hydroxide. Draw fully the displayed structures of the hydrolysis products. So what is going to happen here is that hydrolysis means the breaking up of. So you are breaking this ester right by the functional group here, and then the alcohol is going to be reformed. So this OH is going to be joined here, and this sodium metal is going by the acid, right? So you're going to get the metal joining to this part, the reactive center of the acid, And this OH is going to reform your alcohol to get your ethanol, right? So always remember that whether you are doing regular hydrolysis or alkaline hydrolysis, this is alkaline hydrolysis. You are always breaking the ester into two parts. So, however you get the ester, however you form the ester, you are going the opposite direction. That is why with an ester equation, with an esterification equation, you would get an arrow going forward and an arrow going backward because it's easy to go forward as well as it's easy to go backward to form your products and your reactants. Name the byproduct of saponification of fats and oils. You have glycerol. Glycerol is formed, right? Here we have hard water again. State one difference between the effects of using soaps and soapless detergents on hard water. Soaps react with calcium and magnesium ion in hard water to form an insoluble scum, which prevents them from lathering easily and reduces their cleaning efficiency. In contrast, soapless detergents do not form scum with hard water ions, so they remain soluble and produce lather readily, even in hard water. So this is kind of cool to know, right? Soaps and soapless detergents. Soaps react with calcium and magnesium ions in hard water to form an insoluble scum, which is the scum that I was talking about earlier, the white, sometimes powdery stuff that builds up on your pipe, right? Um, Soaps react with calcium and magnesium ions in hard water to form an insoluble scum, which prevents them from lathering easily and reduces their cleaning efficiency. In contrast, soapless detergents do not form scum with hard water ions, so they remain soluble and produce lather readily in hard water. Good. Figure 5 shows the structures of an amino acid and protein. State the type of polymerization in the amino acid in figure 5. So this is also bio because your amino acid is your monomer for your proteins. It would undergo condensation polymerization. Part 2 state the general name for the type of polymer formed from the amino acid in figure 5, polypeptides, right? State two chemical tests that can be used to distinguish between propene and its polymer. So with alkenes, we know that there is a popular test that we use. We use the bromine water or the acidified potassium permanganate. So if we add bromine water in each sample, the propene will decolorize the bromine water and no color change or no reaction will happen with the polypropene. For test 2, the acidified potassium permanganate, if you add it to these two solutions of the propene and the polymer, the propene will have a reaction, meaning that it will decolorize the purple potassium permanganate and the polypropene would not change. So basically, you are just looking at a visible change, a reaction that will give you a visible change to for you to indicate something is happening, right? Number six, A, part one. Farmer Brown reaped a crop of vegetables and reported that the yield was far below what was expected. An analysis of the soil revealed that there was a deficiency of magnesium. Part 1 outlined the importance of magnesium on plant health. Magnesium is mainly present in chlorophyll. Chlorophyll is essential for photosynthesis. And without the magnesium, you won't have photosynthesis. Without both of them, plants cannot make food. Photosynthesis is the process by which plants make food. Part 2. Explain how a magnesium deficiency can result in the low yield of vegetables. When a plant does not get enough magnesium ions, it produces less chlorophyll, causing the leaves to turn yellow, especially between the veins of older leaves. This condition is called chlorosis. With reduced chlorophyll, the plants cannot absorb sunlight effectively. So the rate of photosynthesis decreases and less glucose is produced. Right? Remember, photosynthesis is the process by which plants make food. Since glucose provides energy and materials for growth, the plant grows more slowly, produces fewer or smaller fruits and vegetables, and overall crop yield decreases. Right? So that's just some cool things to know about magnesium. Part 3. State two other metal ions which are important to plant growth and the results of each deficiency. So calcium, if you have a lack of calcium in your plant, you will have a stunted growth, meaning it wouldn't grow to its full potential. And iron, you would have the yellowing of leaves, right? Your leaves would turn yellow. Right. Last question of this paper. The Caribbean Sea and many oceans around the world have been found to be polluted by solid waste, mainly in the form of plastics. State two examples of plastic waste that are commonly found in the seas and oceans: single-use plastics and plastic bottles. Discuss two harmful effects of plastics on marine life. Marine animals like turtles, the season that we are in, marine animals often mistake plastic for food. For example, sea turtles may confuse plastic bags with jellyfish, and fish and seabirds consume microplastics. These plastics can block their digestive systems, making them feel full and causing starvation. Harmful chemicals from the plastics can also build up in the food chain and eventually reach humans through seafood consumption. Marine animals can also become trapped in plastic waste such as discarded fishing nets, six-pack rings, and ropes. These materials can wrap around their bodies, preventing them from swimming, and it happens a lot to turtles, feeding or breathing properly, which may lead to drowning or serious injuries. Additionally, plastics can cover coral reefs and seagrass, blocking sunlight, while microplastics can carry harmful pollutants so that interfere with the hormones of marine organisms. So really and truly, this is something that you need to know. Nice, very interesting information. So in the event that this topic do come in the exam, you would be able to discuss it further. You don't have to learn it word for word, but you can discuss it in your own words. Once you understand the basic gist of it, you can rewrite it in your own words. Okay, so this is the end of yet another past paper. So we can take a 10-minute break now. We will come back at exactly 4:30. We are back with June 2022. Let me know if everybody is here and functioning. Yeah, yeah, we functioning. That's great too. You're able to concentrate for a long period of time. Right, so I'm gonna start. Oh, forgot to stop recording. All right, so we continue and recording. Okay. So you all seen the paper, right? You all seen the past paper because I had stopped sharing. You all seen the paper? Okay. All right. So question one. An experiment was carried out. An experiment was carried out to determine the energy change. So enthalpy. This is our first enthalpy question for the day. An experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid. Immediately, magnesium metal and hydrochloric acid. Metal plus acid gives you metal salt plus hydrogen gas. Mg solid plus HCl aqueous, forward arrow, MgCl2 aqueous plus H2 gas. So an experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid. The procedure is given below. 100 cm cubed, so we have some moles that probably we may have to figure out, right? 100 cm cube of 0.5 mole per dm cube hydrochloric acid was measured and placed in a calorimeter. So you have your calorimeter set up. Remember, your calorimeter always needs to be covered so that you won't always have, or you will minimize heat loss to the environment. So you have your thermometer, your calorimeter, and you have 100 cm cube of 0.5 mole per dm cube hydrochloric acid measured and placed. Sandpaper was used to clean a strip of magnesium ribbon until shiny, and 0.48 grams was weighed using a balance, right? So this is 100 cm cube of 0.5 mole. Remember, in the beginning of the class, I started off saying that when you have these lab experiment questions, you need to picture yourself doing the actual experiment in the lab so that you can clearly understand what is going on. The temperature of the hydrochloric acid in the calorimeter was measured every minute for 5 minutes until a constant temperature was obtained. Looking like a thermometric. The magnesium strip was then added to the calorimeter with hydrochloric acid. While stirring gently with the thermometer, the temperature was recorded every 15 seconds for 2 minutes. Figure 1 shows the first 5 temperature readings taken during the experiment. What is the first temperature reading? 33. 39.5, 43, 44.5, and 46. So let me just write this in the corner here so we wouldn't lose it. 33, 15 seconds. Um, 33, 39.5, 30 seconds, 43, 45 seconds, 44.5, 60 seconds, and 46, 75 seconds. Good? Right. So we have to, well, we have our table here, right? Um, 33, um, 39.5, 43, 60, 44.5, and 46. Right, so we have those there. Sorry. All right. Using the grid provided on page 7, plot a graph of temperature against time using the data in table 1. Draw the best curve through the points. So let me just go back to the table. We have 0, 25, 15, 33, 0, 25, 15, 33, 30, 39.5, 45, 43, 60. So I could go with 90, 45.5, 105, 45.5, and 120, 45. All right. 0, 25. That will be here. It's temperature. Right, so 0, temperature is 25. Right. So that would be here. Right? 1533. So let's find the points now. 35 minus 30 divided by 10. This is what we would have done earlier. 0.5. So 30.5, 31, 32, 33. So this is 33. 15 33. All right. Um, After you get 15, 33, 30, 39.5, which would be right here. 30, 45 seconds, 43, 40, 41, 42, 43, 60 seconds, 44.5 should be right here. 60, 75 is 46, 45, skip 2 lines, 46, 90, 45.5, 90, 90, 45.5, 105, 45.5 again, and 120, 45, which is directly on the line. Let me see if I can zoom up. This needs to come up a little bit. And right, smooth curve. Let's see how we could draw this. That is not even beginning to be smooth. Just note. Oh wow, that's as smooth as it could get. I think we're missing a point here. I don't know where that point went. That's as smooth as it could get, right? Everybody okay? All right, good. All right, lovely. So that's as smooth as it could get. All right, so we have our working, everything. Use your graph to determine the temperature change for the reaction. So how would we get the temperature change? The temperature change would be the difference the temperature change would be, what is your highest temperature? What is the highest temperature we have here? Can anybody tell me the highest temperature? We have to get the difference between the highest temperature and the lowest temperature. 46. And what is the lowest? 25. Excellent. 25. So 46, that's 21 degrees Celsius, right? State one difference between endothermic and exothermic. Difference between endothermic and exothermic. Anybody could tell me? So endothermic is the energy absorbed from the surroundings. Exothermic is the energy released to the surroundings. So in endothermic reactions, energy is absorbed from the surroundings, and in exothermic reactions, energy is released from the surroundings. State whether, state whether the reaction between magnesium and hydrochloric acid is endothermic or exothermic. What you all think it is? It has a positive energy change. With endothermic reactions, reactants have less energy than the products and vice versa. Very good. Very good, Hayden. That's also another way to look at it. Excellent. Right? Very good. Magnesium and hydrochloric is endothermic or exothermic? Anybody could tell me? Endo. Why do you say it's endo? Very good. Because, so let's look at it. Let's look at it, right? If we look at the graph carefully, right? In the graph, we can see that the temperature in the reaction vessel is what we are measuring, right? So there is a rise in temperature until 46, and then it is starting to drop. So do you think that energy is being absorbed from the environment, or do you think energy is being released to the environment? Look at the graph. You have a rise in temperature, and then you are reaching a maximum, and then you are dropping. Do you think do you think you are absorbing energy, or do you think you are releasing energy? Because this temperature that we are taking is The temperature of the reaction vessel. As we so because the temperature is rising, this is the fact that the reaction is actually occurring. So energy is being released in the reaction vessel. Energy is being released in the reaction vessel. And due to the fact that the heat energy is now dropping, the temperature is now dropping, it means that in the reaction vessel, heat is actually being released to the environment. Does that make sense to you, Lani? So the fact that, right, so the fact that the energy is being the temperature is increasing in the reaction vessel means that the HCl and the magnesium is being mixed and energy is being released. And where is the released energy going? It's going to the environment. So therefore, that would make this reaction an exothermic reaction, right? Exo, good. Write a balanced chemical equation including state symbols for the reaction between magnesium metal and HCl. So Mg solid plus HCl aqueous forward arrow MgCl2 aqueous plus H2 gas. So we need to be balanced, right? So we would put a 2 in front of the HCl because you have two Cl's here and you have two H's here. So that is your equation for your reaction. Calculate the number of moles of magnesium used. If I remember correctly, we have a mass for magnesium, not so? The mass of magnesium used was 0.48. So we can use the conversion ratio mole equal to mass over molar mass and end up with mass being equal to mole by molar mass. Somebody calculate it for me, which would be equal to your number of moles. Oh, we need to find the number of moles. Sorry, my bad. Mole would be equal to mass, which is your 0.48 grams, divided by magnesium being 24. So that would be 0.02.48 divided by 24.02. Excellent. 0.02 moles. Determine the volume of gas. So for this equation, we will write mole equal volume over STP we using. So volume would be equal to mole multiplied by STP. And we would have calculated the moles previously. So the number of moles would be 0.02 moles multiplied by your STP, which is 22,400. Calculate that for me. Mm-hmm. Hidden like a like maths boy. I only seen your answering for the maths questions. All right. Good. Calculate the energy change for the reaction. So this is MC delta theta. Assume that specific heat capacity is 4.2. The density of the solution is 1 gram per cm cube. All right. Um, so I'll just write it like this. Delta H is equal to MC delta T or delta theta. Your mass. Right. Remember you had Remember you had 100 cm cube of hydrochloric acid, right? So we trying to calculate the total mass of the entire thing. So H is equal to MC change in T. All right, there's a little delta going there. Right. So with respect to your mass now, they are telling you that for your mass, the density of the solution, density is equal to 1 gram per cm cube. So for your mass, you have two things to consider. You have to consider your 100 cm cube, and you have to consider your 0.48, because you have to consider that both of these things, your magnesium and your HCl, are going to be in your reaction vessel. So this is grams. So if we convert this to grams, we'd get 100 grams, and this would be 0.48 grams. So if we add it, we get 100.48 grams. All right. So your mass is 100.48. C is 4.2, but 100.48. And then your delta T, as we found in the beginning, was 21. Calculate that for me. What you'll get. Mm-hmm. That's correct. Very good. Very good. 8862. I just use an 8862 joules. Right? So that is your answer. Hence, determine energy change per mole of magnesium. How much moles of magnesium we had? 0.02. So you just have to, if it's per mole, energy change per mole, right? Would be your energy change being 8862 joules, and you divide it by 0.02 moles. What you'll get? Mm-hmm. Very good. 4. Wait. We gain different things. 8862 divided by 0.02. I got 443100. Just check it back and see. Make sure you'll 8862 divided by 0.02. Check it back and see. Yeah, 443100. Check it back, Lani and Hayden, and let me know. I'll give you all a minute. Yeah. All right. Define the term alloy. So we're doing some metals again. Steels are alloys and widely used in industry in place of iron metal. Define the term alloy. Alloys are a mixture of two or more metals. Two types of steel. You have stainless steel and you have carbon steel. Good? Everybody must have heard about stainless steel before, right? State two enhanced properties of steel. You all know that steel is strong, or it is stronger, and it is resistant to corrosion. Right? All right, let's go. Many metal nitrates undergo thermal decomposition. The relative ease of decomposition and products formed can help determine their place in the reactivity series. Table 2 shows below shows the product formed from the heating of the nitrates of 5 different metals: B, W, X, Y, and Z, respectively. Using the information from table 2, state which metals would be the more reactive and which would be the less reactive. So if you look at the products, right? The products formed with your metal nitrate under thermal decomposition. You have your metal oxide, your nitrogen dioxide, and oxygen. So since you have your nitrogen dioxide in the mix in V, X, and Y, you can see or you can think that, hey, this thermal decomposition was not complete because you still have nitrogen dioxide in the mix. You have your metal oxide, you have your nitrogen dioxide, and you have oxygen. So therefore, just looking at that, your less reactive metals would be V, X, and Y. Your more reactive metals would be W and Z, right? Chemical equation. If one or more reactive metals was identified as sodium, so your reactive metals will give you your metal nitrite and oxygen. See, it's very important. If you got this part wrong, then you would also get this part wrong as well. So your if it was identified as sodium, write a balanced chemical equation, right? So sodium, we heat in the nitrate, NaNO3, solid, forward arrow, NaNO2, solid, plus O2, gas. See if you all could balance this equation for me. Is it already balanced or it need balancing? You all get trouble with balancing equations? Yes, it needs to be balanced. Balance it for me. What do I put where? Two in front, any NO3. That's excellent. Anywhere else? Very good. Very good, guys. Excellent. Good. Let's go here now. Further tests were carried out with metals V, X, and Y. So all of them are considered to be the less reactive metals. Further tests were carried out with metals V, X, and Y. Each metals each metal was the oxides of the other metals in the displacement reactions. V did not react with any of the metal oxide. That's a red flag. X is a red flag. X reacted with the oxides of metal V and metal Y, successfully displacing the metals. This is actually a green flag. This is excellent. And Y reacted with the metal with the oxide of metal V successfully displacing the metal. So that means Y is more reactive than V. So I would say that V is the least reactive. I would say that V is the least reactive, then Y, then X. So they say from most reactive to least reactive. So X is the most reactive, then I would say Y, and then I would say V. Because V did not react with anything. Y could react with the oxide of metal, V successfully, and successfully displacing it as well, right? And then X could react with both V and Y. So X reacting with everything, displacing everything. Y displacing V. So Y is more reactive than V, and V not displacing or reacting with everything. So therefore, the answer to this is X, Y, and then V. Good? Very easy and easy marks. Aha. We have some qualitative analysis. You see how long we had to wait for qualitative analysis? We had to wait a long time for that. A few drops of dilute sodium hydroxide were added to a small portion of solution A in a test tube. Green precipitate formed. Green precipitate formed is always Fe2 plus. So Fe2 plus present. Green precipitate darkened when left to stand and turned orange at the top of the test tube. So that means it may have oxidized a bit and become Fe3 plus present. Yeah? Pungent odor. A few drops of dilute sodium hydroxide were added to a small portion of solution A in a test tube. Um, the test tube was heated gently. Colorless gas evolved with a pungent odor. Gas turned damp red litmus paper blue. That is an alkaline gas. Because it turned in the damp red litmus paper blue, it's an alkaline gas. So therefore, the alkaline gas that we know is NH3 gas. Present. Colorless solution formed. Right? So if it's a colorless solution formed, then your NH4 plus ions are present. Good. Fe2 plus, Fe3 plus. Um, NH3 gas, gas, and your ammonia ions present. Ah, lovely. State the homologous series to which compound A belongs. Tell me the homologous series. Very good. Acid. Carboxylic acid. Good. Sorry. Carboxylic acid. The functional group of compound A. What is the functional group of compound A? Functional group of the acid. Test your skills of what we learned today. Very good. COOH. Excellent. State the name of compound A. Can you name compound A? How many carbons does it have? Butanoic acid. Excellent. Excellent. Good. States whether compound A will undergo a condensation reaction or an addition polymerization reaction with alcohols. So, compound A is a acid. I want you to think about it properly. Compound A is an acid and they want to react it with an alcohol. Think about what happens when an acid reacts with an alcohol. When you think about that, think about your products and then tell me what type of polymerization. And we spoke about polymerization earlier. Is it a condensation polymerization or is it an addition polymerization? Anybody? Con Excellent. Very good, Hayden. Condensation because water is a byproduct. So condensation. Excellent. Condensation reaction. State the homologous series to which compound B belongs. What homologous series is that? Scroll up to see B. This is B. Very good. Alkene. And what is the functional group? C double bond C. Yep. C double bond C. What is the name? Let me scroll up to show you how much carbons it have in that. One, two, three, four. Four carbons. Excellent. Fix that, Lani. Wrong. Very good. Butene. Excellent. Define the term structural isomers. Different what? Same what and different what? You don't need to give me the entire definition, but same what and different what? We coming down to the last of the last. We testing ourselves. Structural isomers. So, right. So, right, Hayden. So just correct yourself there, right? So structural isomers have the same molecular formula but different arrangements of atoms or different structural formula. Lovely. Anybody would like to try drawing this for me? If you don't want to try, it's okay. I'll draw it. So, of compound C, how many carbons does compound C have? One, two, three, four, five. It's a simple alkene. It has five. We can do a branched. So we can do one, two, three, four. We can branch it off at the second carbon. Of course, your H is going here. So that's one isomer. We can also branch this one up here. So have a carbon backbone of three carbons. Put a branch up here. Put a branch down here. Good. That could be your two. Anybody could name isomer one for me? Remember, you have the branch there. So how does the branch contribute to the name? That is on the branch is on the second carbon. So not one methyl butane, two methyl butane. Try the other one now. Two branches on the same carbon. Anybody? One, two, ethyl propane. Met et. So ethyl is two carbons, but you have three carbons in your backbone. So it won't be ethyl. Also, your number is supposed to be the same because it's on the same carbon. Is that your first carbon or is that your second carbon or your third carbon? So it's 2 comma 2, 2 comma 2 because it's on the same carbon. You have two branches on the same carbon, so it's going to be dimethyl. And you have three, yeah, it had three carbons, so propane. So 2,2-dimethyl propane. So what you can do is just practice naming your compounds for now, right? 2,2-dimethyl propane. Very good. Electrolysis. You see, I tell you, they like to test electrolysis, right? Figure 5 shows a line diagram representing the electrolytic cell used in the electrolysis of aqueous copper 2 sulfate using copper electrodes. So, your copper electrodes. State whether electrodes are active or inert. Tell me, active or inert? Do you think that these copper electrodes take part in the reaction? Active. Very good. Describe what occurs at the cathode and anode in the electrolytic cell. Something happens. What we can put, since they didn't ask us to for anything specific, we could say at the cathode, the positive ions or cations will migrate. You can put that as well. Is that at the cathode or the anode? Yes, you could put that as well, Lani. Yes, that is what we did earlier. Yes, at the anode, so I'm gonna put everybody's own. At the anode, the negative ions or anions will migrate. Um, Hayden said copper, solid copper. See you because we did this same one earlier. Copper will deposit at the cathode, and Lani said cathode is reduction, anode, and anode is oxidation. They didn't ask for anything specific, so whatever you think happens at the cathode and the anode, you can put it. State which electrode in figure 5 on page 16 is the cathode and which is the anode. Tell me. A is what? Yes. A is anode. Oh no. Anode. And B is cathode. B part 1. Identify the ions that will migrate to the um cathode and anode. What is your aqueous copper 2 sulfate? What will you have at the cathode if it's aqueous copper 2 sulfate? Very good. So you have your Cu2 plus and H plus, and at your anode you would have your SO4 2 minus and OH minus. Write half equations. So as Lani correctly said, cathode is reduction, anode is oxidation. So I just want to write it here. Cu2 plus aqueous plus 2 electrons forward arrow Cu solid. And bioanode is Cu solid forward arrow Cu2 plus aqueous and add 2 electrons. Using your answer in B part 2, explain why redox reaction took place. Do we know our definitions of oxidation and reduction? In terms of the oxidation state, you can clearly see that copper is going from 2 plus to 0 here. So that is reduction. And it's going from 0 to 2 plus here. So it's the opposite, which is oxidation. And that's it. Hmm, sorry. All right. So at the cathode, the oxidation state of copper changes from +2 to 0, meaning that it was reduced. At the anode, the oxidation state of copper changes or changed from 0 to +2, meaning that it was oxidized. Simple as that. And Hayden said earlier that copper would be discharged at the cathode. Suggest one change that is likely to be observed at the cathode. The mass of the cathode will increase as there will be copper being deposited at the cathode. Good? Explain how the electrolytic cell can be modified to plate copper on a small piece of steel. All you need to do is replace the cathode with the steel, because if copper is being deposited on the cathode, then if it is that you replace the copper cathode with steel, copper will now be plated, or it now would now be deposited on the steel itself. So this is called copper plating. Replace the copper cathode with a small piece of steel so that copper deposited on the steel. Good? Oh, here we go again. Here we go again. State for general characteristics. So let me see if anybody remember. Give me one. Anybody remember? Same functional group, same general formula. Same general formula, same functional group, similar chemical properties, and yeah, yeah, each successive member differs by a CH2 group. Excellent. Perfect. Write the general formula of the alcohol, homologous series, and the molecular formula. Anybody remember the general formula for alcohols? CN H 2N plus oh, that's a zero. It's minus. I mean, it's plus. Plus 1 OH. I thought I was at 10. So it's not a plus 1. It's not minus 1. Oh, I thought you had minus 1. Oh, you edit it. Okay. Sorry. Right, yeah. All right, so the fifth member, we just substitute in N as 5. So C5H11OH. Figure 6 shows the fully displayed structure of compound D. Circle any two functional groups shown on the structure. Let me hear two functional groups. I've seen 3. This one? This one you're talking about? So that's ester. Very good. Right? Very good. That's it. Part C. Guys, it really can't come easier than this. Experiments were carried out on two hydrocarbon gas samples E and F to determine which gas is ethane. Table 4 presents the experiment and observations. Each hydrocarbon was bubbled through bromine water. Hydrocarbon E, orange bromine water, becomes colorless. And hydrocarbon F, no reaction. So state the difference between alkanes and alkenes. Alkanes contain carbon-carbon single bonds. And alkenes contain carbon, carbon, double bonds. Part 2. Using the observation in table 4, identify hydrocarbons E and F. Which one is an alkene and which one is an alkane? Tell me, which one is an alkene and which one is an alkane? Yeah. So E is an alkene and F is alkane. Very good. Say the conditions under which an alkane would react with bromine. Something to do with sunlight? Use UV light. Ethene gas and air. So ethene is C2H4 gas plus, remember I say when we react in anything with air, it's oxygen. So in your combustion reactions, you will get CO2 gas plus H2O. So balance that out for me. How we need to balance this? Anybody? 2H2O, good. Anything else? Three oxygens and two carbon dioxide. Right? Yeah, good. A chemical factory produces pesticides, fertilizers, and, and plastics using synthetic raw materials. Is this a repeat? Is this a repeat? Yeah, same question here. Define. Define the term green chemistry. Same question, guys. That's crazy. All right, let's do it all quickly. A chemical factory produces pesticides, fertilizers, plastics using synthetic raw materials. The factory has been in operation for the past 5 years and is located near agricultural land, small rural community. Recently, the residents of the community have reported significant loss in plant and animal life due to increases in air pollutants, non-biodegradable waste, and algal growth. Two examples of air pollutants. So I would say CFC and NO2. That's just from the last three substances found in the products produced by the chemical factory that may have contributed to the increase in algal growth. Anything to do with your fertilizers, nitrates, phosphates, what else? That's mostly for air and ammonium compounds. Nitrates, phosphates, and ammonium compounds. Define the term green chemistry. So we can take this definition right here because we have it already. Green chemistry is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous materials. Three principles. They ask us for two here. Give me another principle. Anybody? Energy efficiency. Energy efficiency. Yeah. Explain how any of the three principles can be used by the factory to minimize. So here you are actually applying the principles to a real life situation. So let's go. I will apply it for you. One of the principle is a degradable design. All right? Which marks this as 6 marks. So we need to write chemical products. We gain 2 marks each. Should be designed to be degradable. And that makes sense, right? Because when it is, you see, you have a factory and you want to dispose of certain things, it must be healthy for the environment. To be disposed of and be healthy for the environment. Good. Next one, real time analysis for pollution prevention. So you have to consistently monitor processes in real time to avoid excursions leading to the, what's going on there? To the formation of hazardous materials. Preventing waste can lessen the amount of issues faced around the world, like air pollution. Yeah, I could say that as well. Very good. Very good. Very good. Let me just put my third one. And we could consider the one that Natalia put has because she used one of the principles that we had previously. Something is going wrong with my keyboard, guys. Materials used in a chemical process should be considered I apologize for my keyboard to minimize hazard and risk for chemical accidents. Good. So we have degradable design, we have real-time analysis for pollution prevention, and we have hazard and accident prevention. And I think that's the end of the paper. That's the end of the paper. So we did four past paper questions, which is chef's kiss. Very good. We covered a wide range of the syllabus. How we all think the marathon was, the past paper marathon was. Was it beneficial? Was it something I could have done? How y'all think it was? Okay, thank you. Thank you so much. I appreciate it. We sat here for 6 hours and we dug into the deep parts of chemistry. Y'all could see how the trends in the papers come. Y'all can see what they bring in what years and what they usually bring, what they don't bring. But my advice to you, seeing that they changed the structures of the papers, my advice to you would be study the trends in the papers, but don't study the trends in the papers. As what I said earlier, because you never know what could come. But I know for sure that CXC likes electrolysis. But again, you don't know if they could change the structure because I don't know if they have new people setting the papers or whatever the case is. So it's no longer something that I can say outright, right? So it was great being with you all for 6 hours today. Are there any questions you would like me to answer? Anything you would like to ask me?